David?
Hello, Christoph.
Hey,
Hello.
nice to see you.
How you going?
Together with Uluru. Very nice.
Yeah, Uluru.
Do you want to test your presentation?
Yeah, sure, that'd be great.
So you can just click on... I have to do it first. Stop sharing. Okay, now you should be able to share your presentation. Do you see the share screen button?
Yeah. I have clicked that button and the highlights come up over
Then you
the
can
screen.
select.
You see that? Oh, okay, like that.
You have to select the video.
Yeah, right. Yeah.
Yeah, I see it. Looks good.
All good?
All good. So you get the chance to get the coffee, and we will start in 5 minutes.
Sure, thanks.
Cool. See you.
See you. Pretty decent.
Good morning and welcome to the fourth day of our Brain-Computer Interface and Neurotechnology Summer School. So today is the Hackathon day. I show you also a quick timetable of what we are doing today. So our first keynote speaker is David Painter from University of Queensland. He will show us how to optimize non-invasive BCIs. This is very nice. And then we have Martin Walkshofer from g-tec. He will demonstrate us how to run a unicorn hybrid black, how to assemble EEG electrodes, how to calibrate the BCI system, and how to handle the unicorn software suite for doing developments. And afterwards at 1 p.m., so in 2 hours, we are starting the group formation. So at 1, you will get an invitation from Slack to certain teams. So at the moment, we have 30 teams participating in the hackathon, and we have also responsible persons for every team, and they will help you to get started with all the projects. Yannick Roy is talking at 4 p.m. It's another keynote about neurotechnology projects around the world. And then we have Metin Akai, the signal processing godness from University of Houston, talking at 8 p.m. And the hackathon is running basically the whole night until 1 p.m. tomorrow on Friday. And then I stop the sharing of the screen and I ask David Painter to start his video. And I always also unmute him. Hello, David. Nice to see you.
Hello. How are you going?
So I can see you very nicely. I can also hear you. So he's standing in front of Ayers Rock. This is also outstanding, very nice. Please click on the share screen button so that we see your presentation. So David was visiting our headquarters here in Austria a few years ago. This was very nice. And hopefully we can all come very soon to Australia to visit his lab. Okay, I see your presentation.
See it now?
Yeah,
great.
I hear you, I see you, and please go ahead with your talk.
Great. Thanks very much. Thanks very much to g-tec for the invitation, and I recommend if you have a chance to visit g-tec in Austria, you take it up. It's a beautiful, beautiful country, lots to see. Today I'm going to be talking about optimizing non-invasive brain-computer interface systems for free communication between naive human participants. This was work conducted at the University of Queensland, Australia, School of Psychology and Queensland Brain Institute, with co-authors Angela Renton and Jason Mattingly. And actually the code for these experiments is on GitHub. So if you're interested in replicating this, you can go and download them. Yeah, I am coming from Australia. In the background is Uluru, which is somewhere in the center. And here I'm actually in Brisbane, which is in between the Sunshine Coast and the Gold Coast on the east coast there. Lots of nice beaches and good weather. Today I'm going to be talking about brain-computer interface spellers. These are devices that allow you to communicate using your brain by typing on a virtual keyboard, typically using EEG, but other techniques are possible, for example, FNIRS. In the background here is some EEG activity, and this was some of the recordings actually that underlie the experiments that I'm about to discuss. Here is a kind of schematic of what a BCI speller involves. It involves a precision monitor with a high refresh rate and an EEG system. And in this case, we're actually going to be flashing these letters, each at a unique frequency, thereby producing a unique brainwave over the visual areas of the brain. A little bit unfortunate, it's cut off here. We have 4 electrodes at the back and 1 electrode at the front. And I'll describe that in more detail as we go along. And I don't know how well this comes out. There'll be some flickering, but this is the basic idea that there's going to be flickering, it's producing patterns of brain activity, and we can decode those patterns. This method is called frequency tagging. that you flash a stimulus at a particular frequency, and then you can use frequency-based analyses, for example, FFTs, to produce these frequency-based spikes. And in this particular example, there are two concurrent frequencies, a 6 hertz and a 7.5 hertz, slightly different frequencies, but the frequency-based analysis pulls them out quite nicely. On the right side here, it's showing that's happening at the back of the brain, and really just a few electrodes there, in this case, like 5 electrodes. So it's an occipital brain signal, and you can use various techniques to get more information about the signal. For example, wavelet convolution, which allows you to track the amplitudes over time. If you have a flickering keyboard with lots of different keys, lots of different frequencies, you need to use something a little bit more sophisticated than this. This study was motivated by a high-profile piece of work by Chen et al. In 2015 in PNAS, and they made some bold claims in that paper, particularly that they had a very high information transfer rate compared to the competition, and that this reflected a type of breakthrough that they were able to achieve new speeds and new sort of precision out of BCIs versus competing methods, for example, P300, SSVEP, various types of flicker-based methods. So the information transfer rate is just how quickly you can decode information from the brain signal. And the faster you can decode information, the faster you're able to allow communication. You have a thought, you decode it, and then you can move on to the next thought. That's been a big limitation for these brain-computer interface spelling devices. It's a bit like typing with one keyboard, and now you can use both hands to type on the keyboard. And luckily, the authors also provided a description of what their keyboard looked like. So this is the keyboard in action. In this particular case, participants were instructed to spell the phrase high-speed BCI repetitively using cued spelling. You can see the red letter that instructs the person to move their attention and to focus on that location. A big part about how this works is that you can move your eyes to focus on a particular letter. That brings that letter and the corresponding frequency into the central part of the visual field, thereby activating the central region in the visual cortex, which has a large cortical expanse, effectively filtering out the surrounding peripheral information. Let's play it again. There's a lot of nuance in here. One is that people are following the red item. Anytime there's red, move your eyes. You don't need to spell, you don't need to think, you don't need to communicate, you just need to follow red. And if you can do that nicely, then this high-speed BCI will come up regardless of your intentions. So we made the argument in our publication that this cued spelling is a good start, but it's not the complete story for free communication. Free communication involves you having a thought and you translating that thought into the external world of your own free volition. So we took the basic design of Chen et al. And we made some modifications which we believe allow greater usability of the system for free communication. Lots of different changes, two distinct areas. One is for reductions in character selection time, and the other is in increases in classification accuracy. So for character selection time, we, for example, changed the keyboard from alphanumeric to QWERTY. So instead of ABC, it's QWERTY. It's the familiar keyboard layout. It makes it easier for you if you've just been typing on the keyboard to convert to the BCI system. We changed the number of frequencies. We took out numbers, for example, with fewer frequencies. That makes it easier to classify, and we can get higher performance with fewer frequencies. This is probably my favorite change. We added the last 3 classified characters on the top of every key. What that means is no matter where you're looking on the keyboard, those letters will be present, allowing you to keep track of where you are in the phrase. So you don't need to move your eyes to the top. You can stay focused on the key and know exactly where you are. And for classification accuracy, we did things like changing the frequency to a higher range. So rather than 8 hertz, we move it to 10 hertz, because we know that in the alpha range, 8 to 12 hertz, there's a lot of ongoing EEG activity, which is unrelated to the external stimulus. If we go outside that range, we're able now to have a better signal to noise ratio. And we did some other things, for example, increasing the duration of the stimulation, which allows us to have a longer flicker period, more information to decode, and also gives the person more time to think about the letter that they're going to select next. And we also developed an averaging method to increase the SSBP signal to noise ratio. Essentially, for people with low classification accuracy, we doubled the length of the stimulation duration, cut that in half, stitch it together, and then create like a mini ERP, event related potential, which was the average of a longer period, to increase the signal to noise ratio for those low classification accuracy participants. This is experiment 1. Here is the basic setup of the system. On the left side, you see a person looking at a computer screen with various letters there. They're all wearing an EEG cap. In this case, we're recording from 64 electrodes across the head. We're recording directly in real time to the EEG amplifier, doing some basic processing, signal processing steps, including filtering to the 5 harmonic ranges. Whenever you present these flashing stimuli, it's not only a response at the fundamental frequency, but it's also responses at multiple frequencies called the harmonics. You can include those harmonic responses into the analysis to increase your classification accuracy. The classification was based on CCA, canonical correlation analysis. It's very similar to a multiple regression, where we just perform a whole bunch of correlations and we look to see which correlations are the strongest. Correlation with the real-time brain signal versus a baseline period of brain activity we've recorded during a cued spelling period, where we're able to know the ground truth about which letter the person was looking at and which classification would be correct. There's some visual feedback, for example, letters appearing at the top of each of the keys as the person spells. This is the basic schematic of the CCA. I won't go into great detail. If you're interested, there's more information in the paper, and indeed in the computer code on GitHub, you can see in detail how this was calculated. Schematically, we're recording signal trial EEG activity corresponding to the last flicker period, and we're correlating that with template sinusoids, which adjust regular mathematical functions at various frequencies, and template SSVPs. The template SSVPs were generated by baseline training activity and averaging across multiple iterations of cued spelling to create an ERP, essentially, that was filtered to create an SSVP. Each of these is associated with multiple harmonics. So we're performing the correlation not just at the fundamental frequency, but at these multiple harmonics. The correlation is performed across a range of template frequencies. And here our range is roughly 10 to 16 hertz. And the frequency with the highest correlation is the one that we choose as the classified frequency or letter. There were 3 parts to experiment 1. The first part is template training, where we used a red cue randomly to different letters on the screen, and the person was instructed to move their eyes and focus their attention on each of those letters in turn. Each of them flickered for 1.5 seconds with a half a second break, and that was repeated 20 times, so 20 repetitions for each of these letters. Took about 20 minutes, which is okay. And there was another retraining procedure where we doubled the stimulation duration from 1.5 to 3 seconds for people with low classification accuracy, averaging those two periods together to create these mini ERPs, and that took around 34 minutes. So that creates a reference bank of brain signals which we can use as a ground truth. We know what the signal for Q should look like. Now, when people freely spell Q, we look to see if we can see a similar signal in the real-time EEG. Moving towards free communication, we had a classification assessment where the person cycled through the entire keyboard QWERTY. So starting with Q on the top row, going through ASD on the second row, and ending with B and V on the bottom row, repeating that 3 times. But rather than using a cue, the person had to know where they were and just stay in time, stay in sequence, and to be more goal-directed about it. The only indication of where they were these letters at the top of the screen, which indicate the classification for the previous 3. So more goal-directed and less stimulus-driven than the previous Chen idea. And then we went further and we said, we're going to have free communication. What does that look like? You need to be generating internally these words, and you need to be expressing them in BCI communication. So we used a Freudian free association task. The word would be feline, for example, and the person needs to think, what is the first word or phrase that comes into mind? In this case, cat. They would type that out with the computer keyboard. This provides a ground truth. We now know that they wish to freely communicate cat, and then they attempt to spell cat using the BCI keyboard. It's worthwhile noting that they also have the option of a backspace. So if there is a mistake, it is possible to make a correction. But this procedure of providing a ground truth and testing that ground truth against the real-time EEG allowed us to provide communication, and to calculate accuracy of the BCI spelling device during free communication. This is an early, I like to show these kind of videos recorded on your sort of handheld camera as you create these things. This is an early prototype, and you can see that it hasn't incorporated all of the details that we had. We're recording from 64 channel EEG in this case, but even at this early stage, we do have the Freudian free association task in there, which is kind of cool. And we did cut out, and we have these letters appearing at the top of the screen, which again, I think was pretty well developed to that point. But you can see we have, you can always improve these things. We have this top row of numbers, which may be not useful for communication, a comma, a full stop. If you need to communicate, these are not the most essential. Maybe these are for advanced communicators, but not the beginning BCI people. All the people in our study were beginning BCI. They never tried BCI before. And in fact, this was the first real-time BCI experiment at the University of Queensland, as far as I'm aware. Other people have done BCI type things where they try to classify brain activity, but nobody had tried to do real-time brain activity recording and analysis. So it was pretty exciting for us. There were 17 people in the study, and the classification accuracy for the QWERTY assessment, spelling across the keyboard rows freely, ranged from 100% to around 20%. So actually, we were pretty happy with this. 9 people were above 80%, which we deemed in pilot testing as a level that would allow you to freely communicate using that device. Any lower than that, you're making so many mistakes, it becomes inaccurate and frustrating to use potentially. So for these people with above 80%, they went on to the free association task. And for those below 80%, we engaged in a retraining task for those individuals. The retraining, again, was to expand out the stimulation period from 1.5 to 3 seconds of flashing, and then creating this ERP. And you can see on average for that group, we can shift classification accuracy over above the 80%. So really it's a case of whoever the individual is, there is hope for that person. It's just going to be slower with this particular scheme. And I will describe some ways that we can improve this classification performance. But overall, this method of using mini ERPs rather than the single trial EEG seems like a potentially promising way to go forward for improving classification accuracy. For those individuals who had above 80% accuracy on the QWERTY test, they also did pretty well on the free association test with accuracy, again, over above 80%, a little bit lower. So there is a cost to freely communicating, but overall, the device was suitable for those free communication scenarios. A data set like this is very rich in information. So from those basic results give you some indication of the function of the device, but you're also able to interrogate the data in more detail to work out how we might improve the device in the future. And we have a section in the paper titled Factors Affecting Free Communication. And this is an exploration of some of those factors. Here is another representation of the frequency-based signal. You can imagine these frequency-based spikes for each of the cued frequencies. All these frequencies are flickering at once. You're cued with a red object to focus on 10 hertz, wherever that is on the keyboard. And that produces a strong response at 10 hertz. And also at these harmonic frequencies, you can stack the various cued frequencies on top of each other, and you get a really nice picture of the distribution of harmonics throughout. You can see that these colors are brighter here. So there's more power in these lower harmonics. And as you get higher, progressively lower power. You can see here the notch filter at 50 hertz for the Southern Hemisphere. And again, these are over visual areas of the brain. So we spent some time setting up 64 electrodes, but really, if the signal is just on a few at the back, maybe you don't need so many, and you'll see that in just a moment. But we asked what distinguishes those individuals who have high classification accuracy from those with low classification accuracy. We can do a subtraction of the overall amplitudes evoked by the various frequencies during the cued spelling. And we see that the high accuracy individuals have higher amplitudes specifically at the first 3 frequencies. So it's this low frequency information that's telling us whether you're going to be a high accuracy or a low accuracy individual. In fact, what you can do is you can correlate classification accuracy with the mean SNR, signal to noise ratio. And the way that's calculated is, for example, if you take 12 hertz, you calculate the amplitude at 12 hertz versus the amplitude at adjacent frequencies. That gives you the signal to noise ratio. You can average that across a range of frequencies. And you can see that these are individual participants, their signal to noise ratio average across a range of frequencies was highly correlated with the classification accuracy. High classification accuracy, higher signal to noise ratio, correlation of 0.84. Not particularly surprising, but it's notable. If you don't have the signal there, it's going to be difficult for you to perform classifications. The stronger the signal, the easier it is to perform classification. So in these types of experiments, the very first thing you need to do is try to do whatever you can to maximize the signal. Here is another representation, more traditional representation of amplitudes across a range of frequencies. And you see that these higher frequency ranges on average across the participant pool, they tend to have better amplitudes than these lower frequencies. So to improve this device, you could also focus on these higher frequency ranges, for example. Going half an hour. I think we're going pretty well on time. So other things that we can do to contrast high and low accuracy individuals is we can look at the overall correlations between the template frequencies and the cued frequencies. So the cued frequency is the actual frequency that the person was meant to be paying attention to, and the template frequencies were all the recordings across the various frequencies which may not necessarily correspond to the currently cued frequency. You can see strong colors, yellow colors along the leading diagonals for both high accuracy and low accuracy people. This indicates that on average, the highest correlation is between the cued frequency and the correctly corresponding template frequency. For the low accuracy individuals, however, you can see another interesting pattern highlighted here by this box, that for template frequencies in the alpha range, they're correlating with a range of different cued frequencies, or a range of different cued frequencies are correlating with template frequencies in the alpha range. Basically, the alpha range is an area of confusion where it could be any frequency across the range. It is adding in a little bit more noise, particularly for these low accuracy individuals, due to those ongoing endogenous oscillations in that range. We're also able to break down classification accuracy according to how many harmonics. If we include, for example, the first 5 harmonics, this is the pattern of classification accuracy. And that was the setup that we did with Chen et al. They had the same number of 5 cued harmonics. So we use the same, and that's the overall pattern. But you can improve this by individually selecting the appropriate number of harmonics for each of the individuals. And you get a small improvement over the overall classification accuracy. This is the overall pattern across harmonics, and you can see that for both the high accuracy in purple and the low accuracy individuals, that most of the information, most of the accuracy is in the first few harmonics. You get a boost overall, adding in a second harmonic, but progressively, as you're adding in further harmonics, you're getting a reduction in classification accuracy, indicating that these are not contributing useful information for classification. You're just adding in noise, which is interfering with the already good information that you had present. A big question in this type of research is how many trials do you need for training? It's not necessarily particularly convenient to have subjects come in and have them require 20 minutes of training, 30 minutes of training, 40 minutes of training. You're paying them by the hour. EEG takes some time to set up. You also want some valuable test data, in this case, free communication. So the shorter you can make the training, the more useful information you can extract from the experiment. And you can see for the high accuracy individuals, it does kind of plateau. We use a total of 20 training trials, but it could be that we could get away with fewer training trials, say 12 training trials, and have a comparable type of accuracy. Unfortunately, for the low accuracy people, they do get an improvement by increasing the number of training trials, but it seems like they may never reach the accuracy of the high training group just by adding in more training trials. So try a different procedure for the low accuracy group. Here, this is asking a similar type of question. Can can we substitute an individual's templates with another person to forego that training period, thereby improving the efficiency of the design? On average, what you can see is high correlations on the leading diagonal, indicating that for a given subject, number 10, they have the highest classification accuracy when using their own templates. Not surprising, using your own brain activity is good. It helps you. You get higher accuracy on average. What you can see for the very high accuracy individuals down here in the lower corner, if you take their data can be highly classified across a range of different subject templates, including those with low SNR or low accuracy. So that's kind of interesting. If there were a way to determine, for example, using a quick SNR test, do you have high SNR? Do you have low SNR? If you have high SNR, signal to noise ratio, you're likely to be a high accuracy person. Let's skip training and let's just run through a series of different templates. But you could imagine that this analysis runs in the background. The person is collecting data, you're running through the training, you're collecting the information, and meanwhile on another computer, on a separate computer thread, you're feeding in this data and you're trying to work out, can I take a shortcut? Can I forego this training and substitute different templates? That would be an idea for another type of analysis. Here is some table forms. All it's saying really is that for different individuals, you can improve the classification accuracy depending on how many harmonics you include. For example, participant 16 with 5 harmonics, the default, they have 90%. If you specifically play around with the different numbers of harmonics and you find 3, you can see that you can increase the classification accuracy by 6%, which is not small in these types of studies. Anything you can do that raises accuracy even by a small amount is a worthwhile investment. So that was experiment 1. We started out and we made this brain-computer interface. We tried to see if it would work, and it seemed to work pretty well. And we also modified it to make it suitable for free communication. We wanted to take it a step further in experiment 2 to allow communication using the device. So not just Freudian free association, one word, feline cat, but to actually communicate using the spelling device. That would be the next step. And this is what we set up, which was pretty fun, I would have to say. This was pretty fun to do. We had now 2 people. These 2 people were hand selected from our first lot of experiment participants as those highly accurate, 100% accuracy. And for those individuals, we rigged up the system to allow them to communicate in real time just using their brain activity. We made, again, a number of modifications to that. One of the big modifications was to add a chat screen so that you can, once you finish entering text, like you're using your phone, you can check your messages, see where you're up to, so you can see if the other person is typing or not. You can make a reply. And these are actually some sentences that people typed during the experiment, the 2 individuals. Bring sparkly gin as unicorn blood. They were talking about some fancy dress party on the weekend, apparently. And this is not anything that comes out of a book. This comes out of the person's mind in real time during the experiment, during a conversation prompted with the other individual. Here's some technical details of the setup. Here we actually used G-USB amps, and we actually used 5 electrodes. 5 electrodes for SSBP over visual areas of the brain. We introduced an EMG electrode which we had on the frontal area, which we use for jaw clenching. And we use this as an enter key. For the observant among you, you would notice that we don't actually have enter here. We use exactly the same keyboard layout, and we now use the jaw clench as the enter key. That allowed us to keep the same analysis as the previous experiment, and it gave the participants an easy way to indicate that their message had finished. So technically, yes, it's not purely brain, but it becomes better, I think, than purely brain, because you're making it usable and enjoyable. So yeah, we had two GUSBMs, and we had a MATLAB thread. We're using the GUSBM MATLAB API, which is super convenient, and you can see that code if you're using the same system on the internet. But basically, we're reading from the amplifier. We're using a field trip buffer to send that signal via TCP/IP. It's existing in real-time computer memory, and then it's accessed from a separate MATLAB session. So two MATLABs. One MATLAB is reading, and one MATLAB is kind of analyzing. And that gives you good, stable performance, which is what you need in this type of experiment. That's connected to a stimulus thread, and we use the Unity game engine, which has a lot of benefits and is particularly useful for these kind of visual stimulation based experiments. From Unity, we used additional messaging, sending a message to the other person's computer back and forth, and also a status message. So the words that are spoken, the sentences, and the chat we send to the other person. And this is sort of half of it. This is person one, and that same structure is then again replicated for person two. In theory, we should be able to stack this to make it scale with the number of individuals. Here are the results of experiment 2. In A, this shows the different messages across the 1 hour period of recording. Vertical lines are the different messages. These different colors represent different topics of conversation. For example, hunger, greetings, talking about the BCI speller, talking about, oh yeah, Halloween. So yeah, fancy dress party makes sense, right? Talking about the past weekend, talking about Halloween, talking about the next weekend, some vocabulary, house plans, goodbye. And the level of the dots reflect participant 1 and participant 2 speaking. What you can see here is that there are several topics of conversation that are simultaneously ongoing. Much like real conversation, if you're talking with somebody, you will be responding and interacting with the current topic, but you will also have something else in mind, and the other person will have something else in mind. So those conversations occur simultaneously, just like in regular conversation. This is a very engineering way to represent the contents of speech. Each of these rows is a message, and each person spoke about 30 different messages. BCI spoke. The different colors are different letters. What you can see is these messages become progressively longer as the people were using in the experiment. That may be that people were becoming more comfortable using the speller, or it may be that they just found it more convenient to add in more detail in each of those messages, or it can be a combination of those things. And finally, this is a frequency-based plot of the different letters that people used during the experiment. You see the space key was heavily used by both people, participant 1 in black, participant 2 in white. Backspace key was also used. EMG enter key from draw clenching on the frontal electrode was used quite a bit. All of these letters were used. Some of them were not used as often. Q, J, Z, X. That's another clue. We can maybe forego those letters and make the speller even more efficient. Here is some other footage collected that kind of shows a little bit of the speller in action. And I think the most exciting part of BCI, which distinguishes it from regular neuroimaging, is that you're there. You're there in the room, and you can see it unfolding in front of you. You actually see the results, as opposed to traditional neuroimaging analyses, where you might record brain activity and then you'll go back to your desk and then you'll program away or use a graphical user interface, and then through that process comes into the data. Here, all those checks and balances are there already in place, and you can see the data unfolding in front of you. Here is a more polished organizational, allowed, mandated communication propaganda, if you will. But it gives you a bit more detail about how this is working. You can see here, again, there are so many different iterations of this. This version is using now 4 electrodes. I think we used IZ as well in the end. So we used 5 electrodes because we couldn't work out whether it was OZ or IZ, or like where the cap is, which electrode was more important. So we just grabbed both of them in the end. You can see the electrode at the front. The ground electrode is attached to the top of the head. In this case, this person is having some problems with some errors and finding it amusing. Those problems that were arising because I had 4 screens connected, each showing different information, and there were frame rate issues. Even this computer could not handle what was happening here. We also featured our work in a discussion. Actually, the first author, Angela Renton, a PhD student at University of Queensland, penned an article titled "Typing with the Brain: How We Made Science Fiction a Reality." And I'm going to quote myself here because I can. So I said, I read Reddit posts on futurology and was excited by this project's potential. I still imagine developing this into a global brain-based messaging platform. So it would be possible, now that the code is made publicly available, for other individuals to take up this concept and to expand it. So it's no longer just a single individual in a room doing cued spelling of high-speed BCI, but it's a global communication network of people in different areas of the world communicating freely. Thanks very much for your time and listening to this presentation. I'd like to acknowledge the School of Psychology, which funded this research as ECR grant, which allowed us to work on this project. Angela Renton, who did a lot of the programming and a lot of the writing, and Jason Mattingly, who was a mentor for this experiment. If you're interested in reaching me, you can reach me at this address. And again, the code is available for download at Brain to Brain Interface on GitHub. So thank you very much.
Thank you very much, David. This was very nice. Very nice research and experiments that you're doing. Can you click on the Q&A button in Zoom? Then you can see a couple of questions and we can just start on top and go down. So the first one is from Celia. If I understood well, the subjects can move their eyes towards the targeted letter. How do you deal with eye movement signals? And how are you sure you are not decoding eye movements?
Oh, okay. Well, that's a kind of interesting question because if you're getting eye movement artifacts as well, that could be something that you could use to improve the classification accuracy potentially if you knew how to decode uh, those signals. What we find is that the electrode is very far at the back. It's not, it's actually lucky in a way that evolution has designed the brain in the way it is. These visual signals are really as far away as you can be in the brain from the eye signals at the front, which means that the contamination from those signals are the smallest there. Another way to know is that the eye movement signals, if you move your eyes, you produce low frequencies, and these, which would contaminate a range potentially of frequencies, but we're using higher frequencies, and it's very specific to those frequencies.
And eye movements are always below 6 hertz, and you are filtering all these eye movements out, so it's not very dangerous. Then another question, hello, are you using filter bank CCA here?
Yeah, this is FilterBank CCA, and it works pretty well. I would recommend it actually as a kind of go-to. So this Channel 2050 paper in PNAS, they were using this technique. They mentioned it as a type of breakthrough, and I think it has been a breakthrough. I can vouch for it. But you can see also that now there are even sort of faster and more sophisticated techniques that are also coming to the fore. So there are other ways to do it now as well.
And Maya is asking, how do you differentiate between the main frequency and its harmonics? How did you know that these are the harmonics and not the main frequency that we need to take into the account?
What we can see, I think we can answer that question actually going back to one of these graphs. Here. So if you just take the analysis, we can analyze just the fundamental frequency, just the first harmonic, and we get a certain level of classification accuracy. For high accuracy people, around 90%. And if we add a second harmonic, we get a further increase in accuracy. So we know specifically that these low frequencies are generating a lot of accuracy. We didn't actually, the proper test to do this would be to take specifically just like the 10th harmonic and do that individually and compare that. But a lot of the evidence that we've seen so far suggests that it's really signal to noise ratio. For example, if we correlate the amplitude of the signal to noise ratio, the amplitude of these different signals in comparison to adjacent frequencies, that's highly correlated with classification accuracy. And we can see that these low harmonics really distinguish high accuracy and low accuracy individuals. So it seems like these low frequencies are the most important, but depending on the individual, again, that determines how many simulation frequencies you might use. For example, participant 6 did best with 5 frequencies. And actually participant 1, 6 frequencies, 7 frequencies, 3 frequencies, 2 frequencies. So it really depends on a participant by participant basis where the useful information is going to be.
Okay, another question is on the plot of FFT plotted as a function of frequency. The plot with several curves marked as E on the slide. Is it averaged across subject and trials?
Yeah, this is the grand average. So there's a kind of a tension here, right? Because part of it is you want to know how does it work on average, but then again, what we see time and time again is it's not just how it works overall for the group, but you can fine tune it. So these patterns will depend on the different individuals, and particularly what you're going to see is that if we were to do this with the high versus low accuracy, that potentially the high accuracy individuals may have higher amplitudes in that range.
Thank you. The next one is, how do we interpret the variance of the optimal number of harmonics across subjects?
How do we integrate, how do we interpret the variance
Mm.
of the optimal number of harmonics? That's a good question. Basically, people have different responses to these different frequencies. Why that is? It may be something to do with the folding of the cortex in the visual area. That the cortex is just arranged in a slightly different way. I don't think we fully understand. To answer this question, it would be fantastic to repeat this experiment with implanted electrodes. So we could see actually where these fundamental frequencies and harmonics are happening. With EEG, it's hard. You get a smeared signal. It's hard to know exactly where it's coming from. There have been some speculations that the higher frequency harmonics may be distributed in different visual cortical networks, but really that to me is a little bit speculative at this point.
Okay, somebody's asking if the next talk neurotechnology projects around the world, if this talk is 4 hours long. Of course not, it's 50 minutes like all the other talks. In between is just a hackathon, so people are programming and developing the new applications. You don't have to listen for 4 hours. Then Lucy is asking, is this something you could essentially add predictive text to speed up for a globally used app?
Yeah, that's a fantastic suggestion. That's a what you can do. You know that the brain computer interface is going to be noisy, that the real time EEG is going to have some problems associated with it. You know, it's hard to record brain activity. The more you can get the computer into the equation, the better chance you have. And predictive text is one of the most obvious. You could imagine that predictive text could also be almost in competition with the brain-computer interface classification, in that the brain-computer interface is saying it's Z, right? And you've actually, the last two letters were TH. So maybe the next letter is going to be E. Maybe that's a better bet. So yeah, I think that's a really good suggestion and one good, fruitful avenue for future investigation.
Then Alexander Hudson is asking if you could go away from the chat area more to a web browser. So instead of typing in
yeah. Yeah. That's the way forward for this. I think that uh, all of these signals are existing in these memory buffers, and from there you can just intercept. So the MATLAB, for example, tells you letter T. That's in computer memory, and from that letter T, you then can put it into Facebook or you can put it into MSN. I think that's going to be the exciting thing when people actually, yeah, the integration of and brain-computer interface, right? Is the integration of engineering and computer science. Once more of these computer science methods meet with engineering, it's going to be pretty exciting, I think.
And Helio is saying, great presentation, David. Thank you. Have you considered using audio input instead of visual so that you can do it completely without eye gaze?
I have not thought about that, but I'm very keen to be interacting with people, with patients, with neurodegenerative diseases, for example, and seeing what I can do as a neuroscientist, neuroengineer. If there is some way, you know, that was one of the big motivations originally, anyway, for these BCIs. You read in the initial paragraph that it would be people with paralysis, people with locked-in syndrome need ways to communicate. Therefore, we did this. Definitely, if audition or vision, touch, whatever works for that person, I would be interested in doing that with them.
And then Manuel is asking if it's possible to reach the professional typewriting speed. I guess he means like typing with 10 fingers. Any chance to reach that?
Yeah, and Manuel also talks about the expense. And I think here actually I'm interested in companies like g-tec. And I think coming up the next talk, maybe the unicorn system. I think that these consumer level EEG systems is going to be the next exciting area. And I don't necessarily think that it's going to be typing because, of course, you can type using the hands. There's this whole new manner of interacting with computers using your brain activity. And once we can get the BCIs into people's homes using these budget neuroimaging systems like Unicorn, that gives us great potential to develop these new techniques and new paradigms of brain-computer interaction.
And if you use the Unicorn, then it's already like 10% of the price of an eye tracker that patients are using, just to give you an idea. And James is asking, is the optimal number of harmonics consistent across days or weeks?
We haven't done that. I think that's where a home user market would really come in. You can see that this experiment is quite involved in the laboratory environment. But if we were able to reach a home user market, then we could have data collected like this, and we would be able to answer this question. So to me, the logical next step is to try to get this into consumer hands. That would be my argument. So we can answer these types of basic scientific questions.
Okay, so David, this was very nice. Thank you very much for the presentation and great to hear something from Australia.
Thank you very much. That was fun. And I'm enjoying listening to these talks. Thanks for tuning in.
So have a good day. Thank you very much. And in the meantime, I look for Martin Walkshofer. He's our next speaker, and I ask him to start the video and also enable his microphone. So I can already see Martin and also Leo. So these are the guys helping you with all the programming projects in the afternoon in the hackathon. Martin, please say something.
Hello,
so
my name is...
I can hear and see you. And do you want to share your screen, or are you doing a preparation now?
I'm going to start with the preparation.
Okay, so Martin is going to show you how to use the Unicorn brain interface. So watch carefully this so that you know how to assemble EEG electrodes, to know how to calibrate the BCI system, and also how to handle the Unicorn suite with all the application programming interfaces and the speller and so on. So please go ahead.
Hello, so my name is Martin Walkshofer. I'm working as a software engineer at g-tec, and I'm mainly working on the Unicorn. And I'm going to start to give you an insight into the Unicorn, into the hardware environment, into the software environment. And I'm going to show you how to spell with the Unicorn, how to use the P300 speller, and some software interfaces that we created for the hackathons and so on. So I'm going to start with the hardware a little bit. So this is the Unicorn. I already assembled it a little bit. You have the amplifier, a cap, and 8 electrodes. These are 8 passive electrodes. The Unicorn is sampling with a sampling rate of 250 Hertz. And when you get the Unicorn, you first have to assemble it. So you have 8 electrodes. These are the electrodes. I hope you can see them. These are hybrid electrodes. You can use them with gel and dry. That means you can try to acquire data without using any gel, and if you don't get a good signal quality, you just add some gel and the signal quality should become better. First of all, you have to put all the electrodes into the cap. So there are 8 holes in the cap. You can see the caps and the electrodes, and you just have to slip them in. There are two areas. The lower one is for the cap, and the upper one is for the electrode clip afterwards. So now the electrodes are in the cap, they're mounted. And the next thing is you have these electrode clips, and they are labeled with numbers. So the unicorn is assembled from the front to the back, from the left to the right, and the first channel is channel 1. Then in the next row, the left one is channel 2, 3, 4, 5, 6, 7, 8. So that's how you assemble the unicorn. So just slip the cap onto the electrode, and the unicorn should be prepared. So I've already assembled all 8 electrodes, and there are 2 special electrodes, the ground and the reference electrodes. For these electrodes are used to acquire EEG signal to a specific reference. That's a spot where it's just a little electrical activity. So you measuring all the electrodes in reference to this point. When you have the unicorn assembled, you just put the electrode cap on, and the middle electrode is CZ, and CZ should be in the middle of enion and nasion. So if you rotate 90 degrees, that's the nasion, and in the back there's the enion, and this electrode should be approximately in the middle. So you should prepare the cap according to this. You should ensure that the cap has a tight fit, so all the electrodes are touching the skin. If they are not touching the skin, you're not able to get a good signal quality. So just ensure that the subject head fits well. Then I prepare all the electrodes. I just rub them a little bit so the electrode pins get rubbed through the hair and touch the skin. The last thing to do is to put on ground and reference electrodes. They are labeled left and right electrode. So for these electrodes, you have some disposable electrodes. These are these small electrodes. So you can just use them once, and we usually place them around the mastoids. So that's a small bone behind the ear. You can feel it pretty well. And we use that spot because there's just a little electrical activity. If you go too low, you will have more muscle artifacts from the scalene muscles. So you should try to really put them on the bones, because then you have fewer artifacts. So usually I try to get rid of the hair a little bit, put off the disposable electrodes, and put it on the mastoids, and ensure that they really have a good fit, because otherwise the reference potential is floating and you will have floating signal channels. And on the other side, the same thing. All right. That should be the mandatory preparation steps for the hardware. In the end, we turn on the amplifier. That should be it. Now I'd like to share my screen. How do I share the screen?
Just click on the share screen button.
Oh, yeah. Got it. I hope you can see the Unicorn suite right now. Perfect. That's the Unicorn suite. Basically, that's a software environment where you have some applications, some development tools. You have a tab for licenses, because some of the programs are licensed, one of the programming interfaces. You have a tab for checking the hardware environment of your computer. You can check if you have the right Bluetooth dongle inserted and in use. You can test the connection to an amplifier and detect new amplifiers and pair, and you have access to the user manual. So basically, if you have any questions, most of the things should be described in the user manual, especially in terms of the APIs and so on. If you want to program something, you will find the complete reference there. And also for all the applications, you should have a quick start guide, and we have some video tutorials on YouTube also. So you can also check this afterwards in the hackathon if we don't have time to answer all the questions. Just also check the user manual and the YouTube videos and tutorials. So I'm going to show you how to pair with a Unicorn, how to start the data acquisition. Then I turn on the amplifier. And we have to wait until the device is detected. It might take a while until the scanning dialog detects the Unicorn. Close the wrong window. Now it found it. So if you want to pair with a device, you just select it in the Discovered Devices dialog. And the system should ask you if you really want to pair. Or not. If it doesn't work from this dialog, you can also use the Bluetooth and other devices dialog and pair the Unicorn in there. It's basically using the same API. Seems like my Bluetooth adapter is stuck.
So while Martin is setting it up, I would like to take the chance to let you know, because so many people are asking, at 1 p.m. we will send out the Slack invitation by email, and then you can just click on the link, and this will allow you to see the different hackathon projects. So we assigned numbers from 1 to 30 because we have 30 teams. And when you register for the hackathon, you had to click on one of the little icons, and this defined the order how we assign you to the hackathon teams. But in Slack, we can also move you from one team to another team if you want to join another project, or if your friends are in another team. It's pretty flexible, and we can also do it afterwards.
Okay, seems like the device I've been using is damaged, so I'll quickly switch the Unicorn because the other device is already paired. Then I can show once again how to assemble the Unicorn. I wanted to prepare that, but anyways.
So Martin linked the Unicorn suite already to another Unicorn sitting also on his table. That's a Bluetooth connection, so you need a Bluetooth dongle inside the computer, and then you can search for different devices in the room. With the serial number, you can identify the Unicorn that you want to use. So he mounted another Unicorn on Leo, and now he is just switching it. That's also nice because the Unicorn has little clips, and with the clips you can attach it to the polymer electrodes. These are these hybrid electrodes that you can use dry or wet. And there's also a little magnetic holder on the back of the cap, and the Unicorn is just flipping on with the magnet. So it's very easy to assemble, and now you can see he has these 8 cables for the 8 electrodes, and he can just put it on. Underneath the electrode cables, there are little numbers, 1, 2, 3, 4, all the way to 8. And this allows you to identify the different channels. Normally with channel number 1, we start on the frontal side. Channel number 2 is then the vertex, CZ, and so on. So it's always seen from above and behind. And we go from the left frontal corner to the back corner on the right-hand side. And in that way, we always know the sequence of recording channels. So you can see he can hold with the left hand the polymer electrode, and with the right hand he can put on the little clip to the electrode itself. Now it's assembled, and he's coming back to the Unicorn Hybrid Black suite.
Okay, I'll share my screen again. Is my screen shared? Yes. Yeah, okay. So right now I will show you how to check the signal quality and how to prepare the electrodes. So this is the Unicorn recorder. That's basically an application where you can filter data, record data to a CSV file. You can import the CSV file in different signal processing frameworks like MATLAB or Python or any similar framework. So you can see a data scope in here. That's where we will see all the channels floating in afterwards. And I will set the bandpass filter from 2 to 30 Hertz, and a notch filter from about 50 Hertz. So that's what we usually use for pre-processing. If we have dry electrodes, we usually have a higher high-pass cutoff frequency, like about 1 to 2 Hertz. Sometimes we also use 0.5 Hertz. It also depends on the paradigm you're using. If you on the frequencies that you want to inspect. For instance, if you want to use a P300, you should not go above 1 Hertz or 0.5 Hertz. If you just want to look at frequency ranges like alpha waves and so on, you can go up to 5 or 8 Hertz for the high pass cutoff. So I will now take for the dry electrodes 2 to 30 Hertz and the 50 Hertz notch filter. The 50 Hertz depend on your area. So if you're living in the US, you might have to use 60 Hertz because the power line hum is about 60 Hertz there. And if you're in Europe, we usually have 50 Hertz power line hum. Can you maybe go a little further? So now we have a lot of floating channels. So I'll start to prepare the ground and reference electrodes. If we have artifacts on all of the channels, it's usually a problem with ground and reference. And if we have like jumps like this, we might have an issue with the Bluetooth adapter. So that looks pretty good right now. So if Leo could close his eyes for a couple of seconds. We now have some artifacts, but also a lot of artifacts, a lot of alpha waves in between. So now we see a lot of alpha waves. Open your eyes again. And now we see baseline EEG again, so you can close your eyes once again. And now we see alpha waves again. So you can blink your eyes a couple of times. So now we see huge artifacts due to eye blinkings and some data loss. And lost the connection. Okay, now we have good EEG again. I think I'll shortly get rid of the camera because I think the USB port is overloaded. I hope you still can hear me. So now we have a fluid connection. Seems like my USB adapter was not powering the Bluetooth well. So now it's way more fluid and we can see clear EEG. We still just use dry electrodes right now. So actually that's a pretty good signal, should be sufficient for spelling P300s, for doing SSVP experiments and similar. On the right side, you can see the signal quality scope. So all the dots are green. And now if Leo is clenching his teeth a couple of times, we induce muscle artifacts, and all the channels with high amplitudes, so clench really hard for a couple of times, turn yellow. And if they turn back to green, then the signal quality, the EEG, should be again in a range of plus minus 100 microvolts. And that's what we classify as a good EEG. Okay, in the recorder, if you press the record button, you will store a CSV file, and you can use the CSV file afterwards for processing. That's basically what you can do with the Unicorn recorder. The next thing I'm going to show you is how to spell with the P300 speller. The P300 speller, you can use it for writing letters, but you can also use it as an input for controlling a drone or a robot or any device, basically. I will show you some examples afterwards. So that's the P300 speller. On the right upper corner, you can see whether the device is connected or not, the signal quality, if you trained the system already, if you have a classifier adopted, and if you're sending commands out via the network output. And using the network output might be interesting for the hackathon projects, because you can use this network output in your own application. We have a C# interface. We also created an interface to acquire these outputs in Unity and so on. So you can easily use the P300 pre-processing for controlling your own applications. So here you can see again the signal quality, and we can check again if we can detect eye blinks. So blink your eyes a couple of times. We see it especially in the first channels, because they are the closest to the eyes, and these are EUG artifacts. You can clench your teeth a couple of times again. Now we see EMG artifacts coming from the muscles of your chin. You can close your eyes once again, and we see big alpha waves. So that's actually pretty good and should be sufficient to measure EEG and to use the P300 speller. And first, we have to train the system to adapt to your individual EEG. So we use 5 letters, and my colleague now has the task to focus on these letters only if they're flashing, and ignore all the other flashes. So the speller is going to flash rows and columns, and he has to perform a mental task to provoke the P300 potential. So if you're just looking at the screen, you're also and concentrating on one icon, you're also producing a visually evoked potential, but if you're also performing the mental task of counting, you're producing an even bigger response, which is called the P300 response. And that is basically the principle this system is based on. So now he has to focus on the W letter and count until it has flashed 30 times. That's what we can select here. You have different flash modes. You can use single character, then only one icon is flashing after the other. It's producing pretty good P300s, but the problem is that it takes a lot of time because you're flashing each letter after the other, and only one letter is flashing at the time. So you have a good accuracy, but it takes a lot of time. If you're flashing row columns, a whole row is flashing at the time, and followed by a column flash. And this is way quicker, so you have fewer flashes, but the accuracy is a little lower because you're overlapping P300s and targets and non-targets. And for the random patterns, you have something in between. It's performing similar as the row column flasher, but it's quicker than the single characters and the row column. So right now I'll choose row column flashes because it's the fastest flashing mode in here. And now my colleague has to focus on the screen and count until the W, in this case George Clooney, has flashed 30 times. So 1, 2, 3, 4, and so on. So whenever he's focusing on the W, we're provoking the P300 response. And if he's ignoring the other flashes, then we don't have any P300 in these signals. And these are the two classes that we're training the system on, and the system learns to differentiate. So now he has to focus on the A for 30 flashes. In total, we have 150 target flashes in the signal afterwards that we're training the classifier with, and over 1,000 non-targets. That's also an interesting fact that we have a different ratio between targets and non-targets. So the system has way more non-target features than target features, and that's increasing the P300 speller performance drastically. And you can see that we use phases for flashing here, because we found out in the study that phases produce better another P300 shape than no phases. So our brains are trained to detect phases, and the P300 speller works a little better if you're using phases instead of just colors. And that's a pretty good, cool trick to increase the P300 performance. Usually the training takes about 5 minutes. And afterwards we can test the system if it really works, if we got a good EEG quality, if we were able to create the good enough classifier to select letters. So the last 2 letters, and then we can test the system if it really worked. After the training, we can speed up the system. It just takes a long time to have a lot of training data. And afterwards, if you're using the system, you can reduce the number of flashes and speed the system up until you're not able to spell anymore. So you have to find your individual threshold afterwards until the system is not working anymore. But we will test that in a couple of minutes. All right, now the training has been completed, and now we can, the classifier is created, and now we can test if the system really worked well, or if we had too many artifacts. So we try to spell BCI, and we start with, now we can speed up the system. We don't need 30 flashes for selecting letters anymore. We can go to, let's double the speed to 16 flashes. And now after 16 flashes, the speller is selecting the most likely icon according to the classifier and the EEG signal. And we can select words this way. So now we check if my colleague is able to control the P300 speller. 1, 2. and the B has been selected correctly. So seems like we got a sufficient classifier. Let's check if we can spell all 3 letters correctly, and if we can do so, then we can speed the system up again. And we can do that until he's not able to classify items correctly anymore. Then you found your individual threshold. You will also see that you will get used to the faces, and you will need some time to adapt to the system. So the performance of the classifier will vary a little bit. And it's important that you have a good EEG signal while you're doing the training, especially during the training, because if the application differs from the data that you've trained on, then the system will not work anymore. So you should not have a lot of eye blinks. You should not use a chewing gum while during the training. You just should focus on the matrix and do nothing else beside. So now he was able to write PCI correctly. So we can speed the system up again. So we'll go to 8 flashes now, double speed again, and try some different letters like GT, GT, and check if we can still, or let's try g-tec, if he's still able to use the system. So again, double speed. Still correctly. So right now we're doing the experiment with dry electrodes. If it would not work, or if you would have too many artifacts because a lot of people are moving around in your environment, you can add gel to the electrodes and ensure to have a better connectivity in between the skin and the electrode. So dry electrodes are more sensitive to electromagnetic field changes, to movement artifacts, and to people moving around in your environment. Now we have the first mistake. And with gel electrodes, you should have fewer artifacts. All right, still 3 of 4 correctly, so we can try to speed it up again once, but now it's likely that we will have more mistakes because we already had 1 mistake right now. Let's try some different letters again. A, B, C. So 1 out of 3. So that means the individual threshold for the classifier that we had right now would be somewhere in between 4 to 8 flashes, because with 8 flashes he was able to spell 80% correctly, and right now he made 2 mistakes. So in this case, you would go up a little bit again, and that's how you find your individual threshold and how fast you can select letters it will take some training. So after a while, you will be able to spell more efficient and more quickly. As a reference, Christoph Guger is able to spell with 2 flashes. So that's pretty quick. So you can select one letter in about 1 to 2 seconds. That's a pretty high speed. And now I will show you some different ways you can use this paradigm to control different robots or installations or paintings and so on. We have different boards installed already with the Unicorn suite. For instance, you can control a Sphero, that's a small robotic ball that you can move around, and you have some arrows in here, and it's basically the same principle. You're just focusing on one icon, and if you're selecting the icon, then the robot will do whatever is defined behind this icon. In this case, it will move forward, or it will change colors, or it will make some crazy moves. I think there also already has been a talk today about the painting, so you can also use this application to create paintings, to move a cursor around. Actually, I can show this application shortly. And for this example, you can also see how the network output can be used to control external applications. So we connect the Unicorn painting to the Unicorn speller, and whatever is selected right now will be executed on the left side. So if my colleague is now changed the speed, so let's try to change the color to red. Let's make the system slow enough that he can control it. About 8 flashes. Check if we still have a good signal quality, and now we try to select red. Now these two applications communicated together via the network output, and we change the color to red, and that's how you can use the system to paint. But you can also use it in a similar way to control a game, to control a drone, to create paintings. There have been a lot of different projects already in previous hackathons. So if you want to get some inspiration or some examples, we have all the projects uploaded on the YouTube channel, on the Brain.io YouTube channel. So you can also check this for the hackathon. And we also have some tutorials and videos for the Unicorn on the GitHub. So if you want to get some information on how to handle the hardware, how to set up the software environment, how to use a specific application, you can find information on the GitHub. And we also have some programming interfaces, some APIs that I want to show you shortly. So first, in the Unicorn suite included, we have a C API, so you can use the Unicorn to acquire data in C or C++. You have a .NET API. In this case, you can acquire data in C#, or you can also include it in Unity, because Unity is also based on C#. But I just have to add that it's just working on Windows in this case. We have a Python API and a Simulink API. So you can use Simulink, or if you have HYSYS, you can also use the high-speed library of g-tec to create signal processing chains quickly. And I'll shortly present the .NET API as an example. So in this case, you will be led to the folder. You have a library folder where all the DLLs are included that you will need afterwards. And you can also check an example on how to acquire data with the Unicorn. So you will need Visual Studio for executing this example. And for every programming application interface, we have an example on how to acquire data in real time. So you will get the raw EEG, the acceleration data, the gyroscope data, the battery level indicator, the counter, with a sampling rate of 250 Hertz. And the EEG, you will receive the data with a resolution of 24 bits. And then you can create your own applications using these interfaces. So right now I'm going to show you the .NET API. In this case, we created a pretty simple acquisition loop. We're getting available devices. We're selecting a device, then we're opening the device, and then we create the loop where we're constantly acquiring data with a sampling rate of 250 Hertz. You can also see some more information about the functions and so on in the Unicorn manual. So right now here we're checking the available devices. We're trying to select the device, open it, and acquire data for 10 seconds in this example. And then we're closing the data acquisition again. And we have exactly the same example programmed in Python and in C and C++. And in Simulink, you will get the block. I'd also like to show you the Simulink interface shortly. And then I will give you a quick overview on the open source projects that we have on GitHub. I'll do that while Matplotlib is opening. So we have some examples for .NET, C#. So in this case, we created a lab streaming layer interface. You can use the lab streaming layer interface to stream data from the Unicorn to PCI 2000, for instance, to OpenVibe or to any EEG processing framework allowing a lab streaming layer input. We created a UDP interface. In this case, you're streaming data over the UDP interface, not via lab streaming layer. Using lab streaming layer might be a little more sufficient because you're already getting the data as a plain text converted in the right format, and you don't have to take care about all the networking stuff. So that's pretty cool if you want to connect different systems quickly. We created a C API for Linux if you want to create your application on Linux. Then we also compiled this C API for the Raspberry. So you can also create mobile applications if you have a Raspberry. If you want to do some offline processing of CSV files or similar frequency analysis, we uploaded some Unicorn recorder files where you have alpha in the EEG, where you have baseline EEG and alpha beta changes, like closing the eyes and opening the eyes again. But you can also record your own data sets using the Unicorn recorder. And for the Unicorn speller, we created a Unity interface showing you how to get data from the unicorn speller that I've showed you a couple of minutes ago, from the network output to your Unity application to control a game, for instance. So I think MATLAB already loaded. Then we have to add the unicorn to the path. And then I can show you a simple demo on how to acquire data using Simulink. So Simulink is also a pretty cool framework if you want to prototype some signal processing chains quickly, because you don't have to take care about data propagation and all that stuff. So that's already implemented in the Simulink pattern. So in this case, we created a model that is basically acquiring data from the unicorn, doing some simple pre-processing, like a 50 and a 60 Hertz notch filter and a 0.5 to 30 Hertz bandpass filter. I hope you can see. Now we can see it. So here you can see the unicorn, and then the data is basically forwarded. We just have to add the serial number to the block, and then you can hopefully see data floating in. Correct. All right, now it's running, and we should see EG data floating in. Now we can see EG floating in. Right now it's still outside of the EG range, but slowly coming in. MATLAB is a little slow, but you can slowly see the EG channels floating in. Okay, now we see alpha waves again, and if it's closing, opening his eyes again, then we see normal EG. Good. I think that should have been the most important interfaces and software and raw insight into the hardware. So you can, if you have some detailed questions afterward, you can ask some questions on the Slack channel.
So are there any questions? Then please ask them in the Q&A. So in the meantime, I already add up there promote to panelist. And Abdelkader, I unmute you and ask you to share the video. So Martin, there's one question coming in. Will we get access to the Python API?
If you have a Python license, you can activate it. Otherwise, I cannot unlock it remotely.
So it's depending on your hosting institution, which software environment and APIs they have, and then you can also use it, of course, if they have it. So I ask Abdelkader to start his video and also unmute him. So let's wait until he is coming. Martin, can you stop the sharing of your screen? Here he is. Nice to see you again. Please enable your microphone.
So hello everyone. Thank you very much, Christoph. Thank you.
Hey, nice to see you again.
Yeah, nice to see you and thank you very much. This is, it was a dream to have a hackathon here in the Middle East and now it comes true. So thank you very much. So we have almost like 5 groups. We have our UAEU student are extremely excited. And unfortunately, because of the COVID-19, we couldn't invite like everyone from the Middle East and from North Africa, but we do believe that maybe next year we will do it. So this time only for UAEU University. So our students, so they are like 5 groups and some of them, they are going to control video games. Some of them, they are going to control maybe virtual environment. And other, they are going to control drone, and some of them are going to control robot, some like a mobile robot. And I have been, teaching some of them, like maybe for 1 semester, how to use like BCI, and it was extremely useful to use like unicorn device for teaching students this like emerging technology, BCI. It was extremely like easy, even for undergraduate student, like BCI needs like kind of multidisciplinary knowledge. So they have to learn more about brain function and even for signal processing, classification methods, how to control, how to use the unicorn, how to be like familiar with the hardware. But I do believe like using unicorn, we solve a lot of problem. So I think now even undergraduate students, they can develop their own BCI and they can do like great job. They can do maybe an amazing project in the future. So thank you very much. And I'm looking forward to see some of my team, my students to win maybe. So I will support them and I will encourage them to have more excited idea, more amazing idea. And yes, so thank you very much again, Christoph. And
your team was actually one of the award winners in Bari in Italy last year. This was very nice, and the team was even on Rai Uno, the main TV channel in Italy.
Yes, thank you. Yeah, my first time when I attend the BCA hackathon, it was in Japan, in Miyazaki, and we won the first place. And the second time also was with my student from UAEU, and they won the 3rd place, and it was amazing. So it was for them the first time, to attend an international conference and to attend this such like international competition, and they did well. So I think also this time, most of my students are girls, so I support them to do more engineering things. So I hope maybe they can do very well.
Yes, they are just posting in the chat that you are the best doctor. Look.
Oh, thank you very much. And yeah, and I hope in the maybe next year, like after this COVID will like disappear. So we will have like this hackathon in the Middle East and North Africa. So this is our dream.
Mm-hmm. Sounds very good. So in the meantime, everybody should have received or will soon receive the invitation to Slack. So here you can already see members which are already inside Slack. So you should actually find your name here. And so that's me. If there's a green LED on, then you know that you are online. So we can see the people that are logged in. And I have a couple of people assisting me. This is Sarah Breinbauer, the Brain.io admin. So she is inviting everybody at the moment. Then we have Christoph Capella. He will be responsible for the data analysis projects to assist. Johannes Grünwald will also be responsible for the data analysis projects to assist. It would be nice if you could also upload pictures of you, because then it's easier to identify people and also to learn to know different people. Martin Balkshofer just gave the presentation, so he will take care of programming projects. And Leo Schreiner was the subject just before, so he will also be responsible for programming projects. And here we see, for example, Mariam is already an invited member for the hackathon. The list is getting longer and longer. Altogether, we have about 150 people today in the hackathon. So I will leave the Zoom channel online. This means in Zoom, you can always ask something. You can also use the chat, but please note that the chat disappears after some time. If you ask something in Q&A, then it stays there until we have time to answer it. What you can also see here in Slack, first of all, under this tab, we have people assigned. Under files, you can see actually all the data sets that we are using for the hackathon. So the stroke rehabilitation, the ECOG data sets, and also publications. And here under channels, you find the different projects. The projects have a project number. So this is project number 1, where they use a brain-computer interface to control a smart home environment. And if you click on that, then you find that 7 persons are already assigned to this team. So you can click here, and then you see who is assigned. So this is Sarah, me, just to help you. If you have any questions, then we have Laila, Leo and Martin are also here to help you. And then we have Rem assigned. And here is the button. We can invite other people. So if you want to change team members, or if you just want to bring somebody else in, you can do it here. And we see with the red with the green indicators here who is already online. And then you find also a description. Here you can add people again, or you can also remove people. And this is private, so only people which are listed here as members will see what you're exchanging here. This is also important for the hackathon, so the teams are competing to some degree with each other. And here it will only be visible to your team, plus the supervisors that we have here. So the second one is, for example, dream painting. And the third one is the zero control and so on. And then we have also this data analysis project. So we have 1, 2, 3, 4, 5, 6 groups who are doing the stroke rehabilitation data analysis. And here you can see that many things are already uploaded. For example, a publication from Mark Sebastian about the recovery system. So here the experimental protocol and data acquisition devices and everything is explained in detail how we recorded the data set. Johannes added also a publication to give you some inspiration how you can improve the classifier. And here you can see the different data sets. So this was, for example, patient 1. The post-testing, this means after the therapy, the pre-testing before the therapy, and P2 is the second patient where we have data on, and this is the third patient. So in total we have about 12, I think, data sets that you can download. It's a MATLAB matrix. In overview, there's a description how the matrix is built up that you can download. And here you see, for example, the electrode locations over the sensory motor cortex. So the description is basically everything what you need for analyzing the data. Then team 18 works, for example, with unresponsive wakefulness patients. Here we have the data of 2 patients with low accuracy and with high accuracy. This means on one day they had awareness, on another day they didn't have awareness. So you should see different states of these patients. And then team 20 is the same, a P300 EEG dataset from logged-in patients. Then we have team 21, 22, and 23 are working on the P300, that's visual speller. In this case, we have 5 subjects online, and teams 24 to 27 are working on the ECOG invasive EEG with hand poses. And team 28 is SSVEP, and also team 29 is ECOG, and yeah, altogether we have 31 teams at the moment. So this is very nice. It's the biggest hackathon we ever did. At the moment we have 150 people. So all these teams are secret. Only team members will see the content. But we have also this Brainio public space. And here you can ask questions which are interesting for everybody. You see, for example, that Cecilia is already inside here because she is going to make an article about the hackathon. And for that reason, she has access to the public space. And here you can just type in messages and they appear to everybody. Then we have coffee breakers. So this is something if you want to talk something else besides signal processing. So this is like you fetch a cigarette or a coffee, then you can chat with other hackathon team members here. But this is again for everybody. And group forming. So if you want to move from one group into another group, you can let us know it here. So you can say, for example, Christoph Guger with email guger@g-tec.at wants to move from team 11 to 1 because your girlfriend is sitting, for example, in team number 1 or whatever reason you have. And then we can invite you into team 1. So this is where you can chat your wishes. And that's basically my short introduction into Slack. And please let me know in the chat if anybody already got the invitation for Slack. So I see that Cecilia, for example, already has it because we have already seen her here in the public place. So she's already communicating. Who else is already online? Anybody who already received the Slack invitation? Christian Michael Knerlich, sounds German, is already inside. So in the next few minutes, the email should come in and then you are able to log in. So check your team. And together with your team, you have to find a way of communication. So here in Slack, you can only chat, you cannot talk, but you could establish, for example, a Skype group or a Zoom group, whatever you want, so that you can really talk with each other to find new ways and new applications. So it's completely up to you how you synchronize yourself with other team members. Okay, so it seems like they're all waiting still to receive the Slack invitation. Will not take much longer. So how many teams are you hosting? You have to unmute your microphone.
Yes, sorry. For now, we have like 5 teams.
Okay, that's nice.
So like 3 of them, they are focusing on using Unity. So they want to develop video games or virtual environment and then control it with the amazing idea. using P300 speller. And another team, they are focusing on controlling drone, and they want also to do some good maybe application for this COVID-19. And another group also, they want to control BB-8 robot. So it's kind of a Sphero robot. We have 5 teams from UAEU.
Okay, that's very nice.
Yeah.
Now
and
we can see that. Please go ahead.
Yes, and all of them, they are working at home because, for regulation here. So, but most of them, they gather together at home, and I think they can do a good job.
So how many people do you have in each team?
Some teams we have like 5 people, 4 to 5, and some we have only 2 people.
Okay.
Yes.
So in the meantime, we can already see that people are getting online. So here on the left, for example, we see already people who started up Slack. And let's check here again in the public space. Maybe everybody who is online can just send a message into the public space, just to know that you are here and that you are able to use Slack. And I check the Q&A in the meantime. Mr. Singh is asking, just to confirm, is there a separate channel for those attending the hackathon? I haven't received any info for the hackathon, so this is just sent out at the moment. That just explains it. Then somebody is asking, since we work with FMI, I have a few questions. I'm new to all these, so like CT scan, MRI, etc., are used for detecting brain anomalies, such as tumors or other issues. I want to know, with functional properties, does FMI also provide some work as MRI in resting state bolt signal for T1 scan? I've seen one of my colleagues getting spots in her scan, and the radiologist said probably it's nothing, so I wanted to know. So this is not part of the hackathon to do FMI analysis, but it's also a big domain. There's another hackathon coming up in August where they have imaging, and they are analyzing these images. This might be a chance to sign up there, and then they introduce different signal processing techniques for analyzing MRI and also FMI data. Then somebody's asking if the invitations are already out there, sent at the moment. And how do we get access to the public space? It doesn't appear on my Slack. Maya is asking, so the public space should be visible actually to everybody. It's called Brain.io public space. The coffee breakers and the group forming should also be visible to everybody if you are inside Slack. Will the presentation format also be introduced? Should it be live demo or a PowerPoint? It should be a PowerPoint with videos inside. So tomorrow at 2 p.m., every team has to give a presentation of what they achieved in the hackathon. So this can be a concept, but it can also be a real working brain-computer interface. But please make videos beforehand, and in the PowerPoint slides you can show these videos. That's important because it's a real-time live demo and many hundred people will attend. So a real-time live demo is too complicated. Please videotape it. This is also very nice if you can provide us the video afterwards, because then we can put it onto the hackathon page and many more people will be able to see it afterwards. Altogether we have 30 groups, about 30 groups, and we get 2 hours to present all of them. So this means we have 15 presentations within 1 hour. So this means we get 4 minutes per presentation. For that reason, we have to switch very quickly from one presentation to the next one. So PowerPoint with video is what we need. So Maya is saying I'm inside Slack, but it doesn't appear. I will ask my experts about that. And also Jin is saying I don't have access to the public space. So I will ask, and I'm back in a few moments. So I just checked about the public space. We also have to give extra access for everybody individually to the public space, so it will require a couple of minutes, and then you will also see that. So we have to enter every email extra. For that reason, it takes a little bit. And then, yeah. You can see that Christoph Capella is already adding people from Chalmers, for example, multi-channel guest from UK, Kartik, and so on. And I'm already getting many messages from Slack that people are just coming in now. So here we can see that Eric and Lee and so on, they are already inside and they are already active. Data analysis logged in. Also here we have already Marcel and Alexander and Maya inside. This is very nice, they already uploaded images. So if you want to know how Maya looks like, just click on her. And this is Marcel. Looks like Switzerland. Maybe. And you see, I can actually observe what they are exchanging, but that's of course very confidential. So I go very quickly away to the public space. This is what everybody should be a little bit later on to see. Same for coffee breakers and group forming. So like mentioned before, if somebody wants to join another group, you can post it here. Coffee breakers is all for the fun stuff. If you want to exchange something, the public space is for the serious stuff, the scientific questions. There's one. Nicola is saying, hi, I can't see public space on my Slack. Takes a few minutes, so we have to add everybody individually to the public space, and then you will also see it. Another question from Redi, I don't have access to the coffee breakers either. Same like before, we have to add it individually, takes a little bit. So I get like every 5 seconds an invitation onto my desktop that somebody is joining in. Here we see already that Mattis joined us. Lee has to add a picture. I'm sure Lee looks better than that. Here we have Nicola. Very good. Lucas has to add something. Mohamed has to add an image. So we have to find a way to make a group picture at the end with all these Slack users. It's about here. Kara needs an image. Very good. Here we have Zeit. Do you know him?
Yes, I think he's from Malaysia or something like this. I think so.
Okay.
I think he took his PhD from Malaysia.
Very good. I'm sure this was very difficult.
I think Nicola, she asked the question about if it's important or necessary to use MATLAB. I think it depends if you want to use Simulink or...
People are welcome to use whatever they want. MATLAB is of course very easy, but other people are using Python, so wherever they have experience is good. Here we have somebody, Shelly. Nice picture. And group 20 is still forming. So it seems like we have the invitations out until group 20 at the moment. We're still missing the picture from Alexander. Mr. Singh. Very good. Oh, that's a picture. Unity Games. So Christian, for example, is able to access already the public space and also the coffee breakers. And also the group forming. I see that in group 25, there's already the first message posted from Johannes, hello there. So he is hosting group 25 for all your answers. Al-Kisa is asking, is this hackathon necessary? Seriously, would like to join, but all my tools in the lab, which I still can't access. So if you don't have access to hardware, you can either join a team who has access to hardware. You can help them with ideas and data analysis, or you can join one of the data analysis projects. Victor is saying, I guess that it's a configuration of the channel that all new users are automatically added to the public channels. So you wouldn't need to add each one manually. This is actually the concept that everybody gets automatically access. Here's Bruno, already posting hello. And please establish your own communication channel via Skype or whatever you would like to use, so that team members can actually speak with each other. I guess a Skype group or Google Teams is easiest for doing that. So team 26, so already posting a hello, you see. Team number 2 is also posting something. And afterwards, you can also add somebody else. So if you have a supervisor sitting somewhere who should help you in the team, then please just add them so they can participate in the chat. You can also do it, of course, on Skype or whatever you use. So this team 18 is already active. We have Marina and Barbara, Heiding and James. So one team member is still missing, but will not be much longer. So here we already have 3 people active. 15. Here we have Rosella. I guess she's from Italy, and Victor. Valeria. I have a Q&A. I didn't receive email to access Slack. So if you logged into Zoom without your name, I cannot really help you. So please post your email and mail into the Q&A, and then I can check if you're already added. Nicola, could we please go in depth what we need to include in the PowerPoint slides for this competition? Sure. I will show you a slide about that. Just a moment. I have to search for it. So this is actually what you should have in the presentation. So first of all, you will find the PowerPoint slides template on GitHub from the Unicorn. I will show you the link in a moment. Then please integrate videos of your presentation. In your presentation, make sure that you do a proper naming of the file name. So it should be the group number first, underline, and then the group name. So I need the number to identify which team is sending in the PowerPoint presentation, and test the presentation before, and especially the videos, to make sure that they are playing. So keep the videos small. Don't upload 1 gigabyte videos. There's no need. So make sure to compress it before, and otherwise it could be problematic to play it. And here you can see the GitHub link from the Unicorn BI. So if you type this in, then you will find the PowerPoint presentation but template. But I can also put it on Slack so that you can just get it from there. So I post the GitHub link also into Zoom, into the chat. So Sarah just informed me that now everybody should have access to the public space. Let's see if we get more active here. Egwitz is also here. Yes, here. So there are 6 more questions in Q&A. Nicola, could we please go in depth? This was already answered. So the template for the PowerPoint is available. Then we have Kinkini Batra to check. Hello, I wonder to know the type of project from FNIRS and EEG control. I have not received invitation. Okay, I have your email, I can check it. Amna is asking, haven't received my invite yet, are they still being sent out? Yes, they are still being sent out. Kinkini is sending the email, that's good. And Laila is also sending the email. I guess you know Laila from your university and still not have access to the public space. Okay, so I will ask now my guys to check these emails individually. Just a moment. So first one is Kinkini Batra. Kinkini.badra from Uni Geneva in Switzerland. So in Kinkini, you are assigned to team 17. And we add you once more to Slack. Geneva is very nice, by the way. So in a moment you should be able to log in. And then we have Laila from the Emirates. So Laila is also added. In a moment you should get access. And then we have Shia from Welltech in India. Check if you're added. Abdel Keda, are you already in Slack?
I didn't check yet, to be honest. because I'm supervising all the students in the Microsoft Teams, but yeah, check now.
Okay. So I can add you, if you tell me the team numbers, I can also add you to all the teams so that you can also supervise in Slack. Do we have Shelly? Yes, Shelly should be inside. Then we have Gabriel Herrera from France, Paris.
Yeah, Christoph, yes, please, if you can add me, because I didn't receive also the link.
Can you put your email that I should use into the chat?
Okay.
Have it. So now you should receive an email with the invitation. So we have a lot, actually all people invited to Slack, but many of them are still shown to be pending in Slack. So please check your email account again. Maybe also the spam folder. Maybe the invitation ended up in spam. So I have about 20 or 30 people listed as pending invitation. So maybe I read them so that you know who is pending. Oh, a lot. So Eduardo from Colombia, Sarah from France, Adil from Hong Kong, Kuma with a Gmail address, Jan with a Gmail address, Aviga Yati with a Gmail address, Sebas with Gmail, 2015-03 from Mariam from Emirates, Belka from Emirates, Ibrahim with a Yahoo, Rao with a Gmail address, Bar89 Hotmail, Marcel with Gmail, Anna online Gmail, Nila Gmail, 2014-04-885 from Emirates, Mavi Peru with Gmail, Lucas from Brazil, Natalia with Gmail, Gabher 3092 Hotmail, 2019-34-158, and so on. So there are many people pending.
Yes, Christoph. Even me, I didn't receive the email yet.
I saw you in the pending list. Can you check your spam folder, maybe? So is the public space automatically assigned, or we have to do it? Because some people are reporting that did not get access to the public space. You should automatically get it when you're logged in. There's the message from Kini. I just joined. Thank you so much. I'm new to Slack and there was a technical glitch from my end too. By the way, I did not receive an email as well. I got the invitation in Slack directly. Any success with the invitation?
Sorry, my bad. It was my mistake. I think I gave you a wrong email. So please use
Okay.
I'm sorry.
This email looks different, yeah. You exchanged the Emirates with the AC, isn't it?
Yes, ACAE, not AEAC. Is the
Okay. We redo it and then maybe you can explain what you are doing to get insight so that everybody knows.
Yes, so as Christoph said, before I joined you, I was in Japan. I took my PhD from Japan, from Tokyo Tech, and then I joined Osaka University also. I have been working also with Hiroshi Ishiguro, and I controlled his Geminoid, like a robot looks like him, using MEG. And when I was in Tokyo Tech, I have been using g-tec to control video games using eye movement, but it was kind of predicted from the EEG signals, not from the EOG signals. And now I have been joining AEU maybe almost more than 1 year. And I start doing some engineering thing. So we start doing some application like controlling drone, controlling robot, or this kind of things. And I have been also, as I said, teaching. I introduce a new course. We call it selected topic for undergraduate student in IT department. So I have been teaching them BCI, brain-computer interface, non-invasive, of course. So, and I ask them to do kind of project, for like their graduation. So most of them, I do believe they are able, to understand this multidisciplinary field, because I think like people from IT, they have this ability, to do a lot of multidisciplinary field. So I have been using now Unicorn, so to do some application, and I am ordering like 2 g-tecs for more like neuroscience studies. So that's what I do. Yes.
So in the meantime, did you get the invitation to Slack?
Yes, I will. Yeah, I think yes, I got.
Can you share your screen to show the others what are you doing to log in?
Okay. So
Maybe. So I stop my sharing.
Okay.
Please go ahead with your screen.
Yes. So here. So I think you can see now my screen, right?
Yes.
Yes. Good. Okay. So I just received an email. Okay. So it's an invitation to join this workplace. So you just click here, join now. And then you have here your name and your password. So you need maybe to create an account, right?
Yes.
So, yes. So we will create an account. So we will put a password. And then create an account. Okay, so you can see that it's extremely easy. Maybe you have to, okay. And now you can see that here we have public space, coffee breaker. Okay. So if I click here, I can say hello. But there is no picture, so I need to add my picture. Okay, let me check. I have one. So go to edit file and try to upload picture. So go to maybe, let's see where I can find my picture. It's extremely difficult, but okay, let me find one picture at least. I think I have one, but okay, so you can see, so it's extremely easy. Okay, maybe a picture. I have, okay, I have here one picture. Okay, so you have to do that. You have to put your picture. It's important.
Good one.
Okay, so here we are. And then if you want to change your name or something, so you can change it. Displayable custom. Okay, so okay, what I do, my number is not important. Okay. So now I think yes, everyone can see my picture here. Okay, good. So if you have any question, please feel free to ask here in this public domain. And here, if you need more, not kind of personal question, but I mean, if you need more, something for relaxing, you want to ask something maybe outside of the hackathon, so we will be more than happy to.
So I remember still the coffee that your team was brewing in Bari. That was fantastic.
Yes, I remember that. Yes, it was extremely funny. Yes. So I can see here maybe 1, 2, 3, 2, 5 teams maybe. Okay, this is flight control. These people, they want to control maybe a drone. Okay, and then here more maybe data analysis. And these people are using Unity. So this is maybe from UAE University. Yes, so please, if you have any question, write it here. And these people also are using Sphero, I think, yeah. And this one also are planning maybe to develop some smart home. So yes, so I think it's extremely easy. So please, if you cannot access to the public domain or anything, so please just let us know and we will be more than happy to help you. Yes, so I think now maybe, okay, I will save my password in case I will forget it. So maybe you don't need, now I don't need to share my screen. So I think you got what you have. Okay, so now most of people are joining us. So I think now, okay, good, great.
So maybe I deleted now all requests from the Q&A after we showed how to do it. If you're still not able to log in, maybe you can type your name and email again into Q&A, and then we can check again individually for you if the invitation is correct. Be careful that your email is spelled correctly. We have seen already that it doesn't work if the email is not correct, of course.
Yes, Leila, you need to add your picture. Okay, so maybe I will stop sharing my screen.
It's top secret, be careful. So at the moment, I don't get any posts into the Q&A. So it seems like people are now having the invitation to Slack. Okay, sounds good. Now
I
we
think
see also
Nicola,
Kinkini having troubles before. Welcome. Nice picture.
Nicola, she said that she cannot access to the public space still.
We can see that many people are getting into the public space, so it just takes a little bit.
Yes, she sent us her email. Maybe we can send her.
Nicola. Okay, let me check.
Yes.
Email some public space comes. So Sarah is checking now why Nicola doesn't see the public space, and maybe we can also explain what happened. And same for so Nicola, now it should work. The same for Rashika, ready actually. Rashika 1997.
I think yes, even Maya, she cannot. Maybe few people they can.
Then Faisal from Pakistan. Check also him. T. Maya Al-Mogi. So Maya, we just added you to the public space. Should be visible in a few moments. And so anybody else who doesn't have access to the public space, coffee breakers yet, or group forming, please. Pablo is saying he doesn't have access. Please post your email into the chat, because then I can check if the email is correctly here. Galaxy, I have a password error. You have to select the password yourself. So Shelly needs, and Pablo, Dilvani, please let us know your email that we can add you to the space. Then we have Gangan Preet Singh and Dilvani Siaran from UK. So we are checking all these emails. Ready, please send us the, got it, good. Okay. Then we have Fatma from the Emirates. And Shelly is saying she got it. If it's a she, not sure. Fatma has 2017. Okay, Fatma is added. What's about Redi? Please. Is added. Then Siran, 2027. Is added. Deepa Dilwani, Deepa. Is added. Then we have Gagam Preet Singh, Gagam Preet.11. Is added. So actually everybody should be added now. So we can see many people in the public space. Jamie, still missing a picture. Tilvani is here. Marina is here. Maya is here. James McIntyre is here. Coffee breakers, we have also people. And yeah, seems like up to now everybody is happy with his team. Then we get another request from Somir. Then Anatoly, the guy with most of the questions during this summer school. Ali Reza Mosheni, and Faisal. Faisal, it seems like you are not registered for the hackathon. So please go, I show how to do it. Please go to the summer school. So to Brain.io. And then you have to scroll down and you have to select one of the teams that you want to join. And then you click on one of these items and then you can enter your name and email. This will allow you to join the hackathon and we will get your contact details. So Pablo is in the coffee breakers now, but not in the public space. And Johannes is asking for the coffee breakers. Alkisha is saying that he or she just registered for the Brain.io logged in patient analysis group. And in the meantime, Johannes and Martin, can you also log in into Zoom so that I can also add you as a speaker? So I will enable Martin in the meantime. Martin, maybe you can explain quickly for which teams are you responsible? And maybe you can also show on Slack how the teams look like.
Okay. I'll share my screen. Oh, on your screen, or should I share the screen?
You can do it with your screen.
So I'm responsible for the unicorn teams, so the smart home team. In this case, we have 9 members. Abdullah, Laila, again, and Dream. Your hacking project team, Leonhard and me are going to support this team. For both of the Your Hacking project teams, so if you have any technical questions, just ask us. I will support the dream painting team with 8 members at the moment. The Sphero team, 7 members so far. Then we have the orthosis team. Well, Leo already posted a video of his orthosis. 5 members so far. The FNews groups, where you can analyze data from a motometry experiment using EG and FNews data. So 2 teams, 9 members, and again 9 members. Then we have the flight control team, where we have 10 members so far. Unity Rehab, 5 members, and Unity Games. So these are the projects Leonard and me are going to support. So if you have any technical questions according the unicorn or software interfaces or something like that, you can ask us.
Mm-hmm. And then I will also ask Johannes to do more or less the same. So please introduce your teams.
Yes, hello, can you hear me?
Yes.
If you want to see my video, then maybe you have to wait for 30 seconds. I have to enable it in the device manager. Otherwise, I can directly share my screen, but I think it's almost done. Enable device. Start video. Yes, here it is. Hey guys. Yes, I can share my screen and I will show you which groups I'm responsible for. And yes, here we are. So I'm supporting 7 groups. 2 of them, and they are already in the chat, so they have already started with having a look at the data and the PDFs. So it's group 18 with 4 members already and 1 or 2 still to come. It's about UWS, so it's about people in the unresponsive wakefulness syndrome. We have P300 data in different stages, so some of them are very good and some of them are not so good. So they are probably just sleeping and not responding to the paradigm. So you can do some data analysis here. And after reading all the introduction, feel free to ask any questions you have, and I will be happy to support you. In group number 19, I will be also your host and supporter. In group 19, we have 1, 2, 3, 4 members, and 1 is still to come. And then I have 5 groups, which are about ECOG hand poses. So it's invasive data. It's recorded directly from the cortex with implanted electrodes. And there's also a publication how to classify those different hand poses, but you can do actually anything you want with the data. So in channel 24, 25, 26, 27, and 29, it will be my responsibility that you will get through this hackathon as well as possible. And actually, I think group 29 is still very small. I think we only have 2 people here. Yes, and they are already requesting that we might be that they want to join with another group. So maybe it will be becoming a little bit fewer groups in the end. But anyhow, so group 24, 25, 26, 27, and 29 are assigned to me. And I think that's it for now from my side. So you can always reach me in the chat here, and I will do my best to support you.
Thank you. And then we are moving to Kapi. So please start your video and I unmute you. I can already see your hair.
Hello, welcome. Hello from my side. I hope that you can hear me. I think you can see me because I can see myself. So let's quickly switch to my screen. Okay, there we go. Share the screen. Let's move to Slack. So I'm responsible for the first group series, which is the stroke analysis. So we have group 12 to 17 here, working on the stroke data. You can see also in the beginning of each chat that there's some introducing publications. There's a series of data sets in MATLAB format with a montage description of the channel configuration. And also I posted an overview of the individual data sets. So you can download them then directly inside the chat. And we can see it here. We can see here that in group 12, there are already several people chatting, being online. So I think 3 are currently online, 2 are still pending. Then we have chat 13. Here we have 2 people online and 3 pending. Then we have group 14 with 2 people online and 2 people pending. Then we have chat 15 with 3 people online and 2 pending. Then we have chat 16 with 3 people online and 3 pending. And 17 with a full group online. Very good. Okay, and then the next topic is group 20 and 30 with the logged in data. So this is data from logged in patients, including publication, overview, description of the data, 8 MATLAB files for processing, and the channel configuration. So you can download it again from the chat. We are now having 2 out of 5 here, now 1. And in group 30, we have 3 people who are actually now communicating in the group. And finally, we also have an SSVP group, which I'm responsible for. That is group 28. Again, here's a publication, a data description text file, and 2 data sets from 2 patients, so in total 4 MATLAB files with estimation of the estimated classification accuracy, so that you get an idea whether or not you should expect a good or a bad result. And in here, we have 2 people who already joined. At the moment, I think they're not online. So let's see. Maybe from the stroke people we can combine a few. I guess in all groups, more or less half of them is full. Yeah. So maybe we should shift a bit. Let's see. Anyway, hello again from my side. And if you have any questions, please place them in the chat below, and then we can handle the progress of the hackathon. Okay, thank you very much. Bye for a moment. Stop the share.
Ich habe 40 € noch. Dann könnt ihr das aufgeben. Hast du schon die Bestätigung bekommen von dem Anbieter? Ja?
Christian, can you hear me?
Ah, yeah, hi.
Hello, nice to have you. So we were wondering if you could show us your nice Schuhplattel video.
So I guess we can speak in German, no, right? Or is someone else in here?
The others are also listening.
Okay. I don't have the lederhosen on right now, but I can show you that, of course.
Sure. Give us some introduction in German live.
Yeah. So you want to see the Bavarian dance with the shoe? I can do this. No worries. Hey Jungs, ich muss jetzt mal den Schuhblatt vorführen mit der ganzen.
Maybe if you get the live performance, that's magic.
Yeah. Can we play some music? The thing is, I'm in a office of a colleague at the moment because we're having another call right now. But I can show you a quick example. But I need the music because otherwise it's yeah.
Yeah.
A bit silly.
Sure. This will be something for our guests from the Emirates.
Ah, okay.
Yeah, it would be amazing. Thank you.
Did you see a Schuhplattler before?
No.
Oh yeah, you will be amazed.
I hope I have enough place.
Kinkini is also watching now. Very careful.
I think we have to record it.
But you know, yeah, that was a bit of that. I'm not a profi or something, but it goes a bit like that. Yeah. So you get the idea, maybe.
It's
yeah,
amazing.
it's amazing. We have to try it. I think we have to try it.
It's good sport.
I'm pretty sure you would win the IEEE award if you're doing this when doing the hackathon presentation.
Yeah, unfortunately, we didn't record the video for that.
I've recorded it.
That's good.
So we will get a lot of money in 5 years if we show it in public. Thank you very much, Christian. This was nice.
Yeah, you're welcome.
And now we move.
Yeah.
You want to say something?
I just wanted to say that it will be hard with doing the blood lab and using BCI, I guess, because of the signal strength. But that would be funny.
Next time. Thank you very much.
Yeah. Cheers.
And Leo, now I'm adding you.
Yes, thanks.
Please go
Hi,
ahead.
yeah, hi everyone. As Martin already told you, I will support also group 1 to 11 for the programming task with the Unicorn. Nice to meet you all, and don't hesitate to ask us questions in the chat. Yeah, I'm excited. Thanks.
Leo, can you also maybe share your Slack just to see if people are active?
Yes. Okay, just share. See the screen? I guess I'm sharing it now. Okay. Yes. So I'm in smart home. I already wrote a message in here. Then it's group 1. Group 2 is dream painting. Group 3 is Sphero. Group 4 is orthosis. That's where I posted a video already of a prototype of an orthosis. I built a g-tec. Then group 5 and group 6 are the FNIRS groups I'm joining. Group 7, flight control. 8, Unity rehab. 9, Unity games I'm joining. And group 10 and 11, the Your Hacking Group projects. I'm also joining with Martin together. Yeah, that's it. Christoph.
Just unmuting again. Thank you very much, Leo. And I guess we go for some moments to silent mode now. So please let us know in the Q&A tab or chat if you need something, and you got your supervisors, of course, in Slack. The next keynote talk, by the way, is at 4 from Yannick, but you can just stay inside Zoom in the meantime. So Helia, you were asking to join a team. Please post me the team that you would like to have in the chat. Helia, hello. And ready, we switched you already to team number 9. So Helia, we can put you into any team where you want to be. Any preference? Data analysis or programming? Data analysis, so we have stroke, ECOG data, LIS, coma patients, SSVP. So which team from the data analysis is smallest, do we know? Yes. Do we know? Mm-hmm. So we need a team for data analysis for Helia Mirabi. Locked in. Maybe locked in? Mm-hmm. Helia, maybe the locked in? And SSVP. Or the SSVP? In each group we have 4 persons already. Okay, SSVP gibt's nicht. So we could put you into the locked in data analysis group, for example. Yes, thank you. So we put Helia Mirabi into the logged in group. Do we have an email? Helia Mirabi. In welchem Team ist Sie gerade? Ich glaube in Golkan. Suchst du mal noch Namen? Helia, can you type in your email? Ich habe es in diese Public Space Gruppe gepostet, die Präsentation. So the template PowerPoint presentation is now also available in Slack in the public group. So I share my screen that you can see where you can find it. Should be in the public group. Let's see. Or where can I find the PowerPoint presentation? So here in the Traineo public space, you find the template PowerPoint presentation for tomorrow when you are giving your presentation. So from here you can easily download it. And then we got the request for Chet Sada to move to group 12. That's the email from UK. Can you let us know in which group you're at the moment, Chet Sada? In 13. And Helia Mirabi, we are still waiting for your email to assign you to the logged in group. Now we have it. Helia.mirabi@gmail. And So hello again, and now we are coming to our next speaker. So I already added Yannick Roy to the panel list. And Yannick, please share your video. Welcome, good morning to Canada. Can you hear me?
Yep.
I hear you also. Very nice. So Yannick is from Neurotech X, and he will talk about the different neurotechnology projects around the world today. And if you click on the share screen button, you can already share your PowerPoint presentation. So he was just successfully running a very nice virtual conference a few weeks ago with many attendees. And our guys are already working in the BCI hackathon at the moment. They are busy. So I see your slide. I see your video, and I can also hear you very well. So please go ahead with your presentation.
Awesome. So thank you very much for inviting me today. I've been following some of the talks, not all of them, but some of the talks of the summer school. Once again, thank you for organizing such an impactful event in the field. Today, I'm going to talk about Neurotech DIY projects. I'm going to give a bit more of a spin towards the DIY hackathon maker-ish flavor, as we've had great talks in the research space, and most of you, I assume, are more coming from that kind of project. So hopefully you'll leave this talk with a bit more exposure of what's happening on the DIY maker scene. And at the end, we'll have a good Q&A section if you want to explore a bit more in that direction. So my name is Yannick Roy. I'm the co-founder of Neurotech X. I'm a PhD student for many years, trying to finish my PhD, but Neurotech X and other projects and hackathons and things like that are taking a fair amount of my time. My background is in electrical engineering and computer science. My PhD thesis is on a closed loop system, so BCI for mainly cognitive training and games. And more recently, I've published papers in using deep learning for EEG signal, like a review paper I published over a year ago, reviewing a bunch of paper in the field. So Neurotech X is an international neurotech community. We started in 2015. We currently have about 20 chapters around the world in different cities doing local events like meetups, hackathons, from small events, small gatherings like hack nights on a regular basis with a handful of people, to larger events, to workshops covering the full spectrum of events. On Meetup, we do have a bit more than 15,000 members. We do have also 23 student clubs at various universities, which I'm going to talk a bit more in detail. And we do have on our Slack platform slightly over 4,500 members as well. So if you're looking to chat with neurotech enthusiasts at different level, from enthusiasts and curious people to experts in the field, to professors in the field, to CEO of different companies in the neurotech space, you're more than welcome to join the Neurotech X Slack and get engaged in discussions. So a couple of our initiatives at Neurotech X, we do have chapters, I said, doing events, Neurotech X student clubs, so mainly targeting undergrads. We felt, and being a very bottom-up organization, we had a lot of undergrads looking for more opportunities to get involved in the field as early as possible in their career, and not necessarily waiting for doing a master or a PhD in the field. So we start doing student clubs in different universities, supporting them, helping them with curriculum, hardware, and organizing an annual competition for them to compete and showcase their projects. Our Slack community, EDU, educational platform as well. So if you go on our website, you'll be able to access all these initiatives. Our newsletter as well, if you want to just stay tuned about the field on a regular basis, from funding, from project, hacking, research. We try to not overwhelm with content, but just every 2 weeks with just good contents that you might want to keep on your radar. More recently, we started Neurotech X Services, trying to help with recruiting and consulting in different companies. Now that we have a lot of talent coming in one way and a lot of companies coming in the other way, we're trying to facilitate that matchmaking and whatever needs there are in the field. So if you're looking for such opportunity, I would definitely encourage you to go on the Neurotech X job board, since we do have a lot of jobs and opportunities both in academia and industry. So NeuroTech X services, as I said, the idea is really consulting and recruiting on both sides. If you're interested as well, please reach out. One last announcement of the NeuroTech X side of things is that we're going to be releasing a book at the end of 2020, which basically is kind of like a aggregation of all the questions we've had over the past 5 years, trying to answer all of them in a book. So all the questions that are coming over and over again, targeting mainly at the beginner, but really the full spectrum of neurotech is covered. So everybody should get the book. So without further ado, I'm going to I'm going to dive right into the hacking space. My personal journey, I've been in the field of neurotech for over 10 years now. And really, the year 2015 was a bit pivotal for me as I attended many hackathons. Some of you that have been following the space for a couple of years might remember the Neurogaming conference in San Francisco that then changed for g-tec, Exponential Technology conference. But back in 2015, they threw a hackathon with the Neurogaming conference. At the same time, IBT, Israel Brain Technology, and Brainiac was having their hackathon in Tel Aviv as well, which I attended in 2015. BrainHack, which is a bit more on the, I would say, fMRI side of neurotech, a bit less EEG, as I assume most of the community here listening is coming from. Or invasive as well, but a bit less about BrainHack, is a bit less about the BCI space, but more about fMRI, computational neuroscience, but a very open community as well, very open source DIY hacker. So very good community. They are doing hackathons on a regular basis as well. So I'd invite you to check out their website. In 2015, they do have one in Montreal and a couple other cities at the same time. BCI Montreal, we organized our own hackathon as well. So NeuroTech X was initially BCI Montreal, focusing mainly on BCI, started in Montreal, and then we expanded to become NeuroTech X. We threw a hackathon simultaneously with Hack the Brain in Amsterdam. And I'm going to talk about that simultaneous hackathon at the same time in a few slides. But it was a busy year, not working on my research, but just attending a bunch of hackathons in different places in the world and developing some skills, working on different projects. Now I'm really excited to see that the ecosystem have really grown in the field. As the field progresses, we definitely see more hackathons, but also competition. And the field is kind of I would say, looking for itself, what kind of events would bring value outside of the research space, but also how can we encourage and empower projects that are sometimes more research, sometimes more hacking. I think that both are bringing a lot of good in the field. So now Brain.io, obviously, you cannot talk about BCI hackathons without talking about g-tec and Brain.io, supported by IEEE Brain Initiative. So if you're interested in more on the BCI hackathons and Brain.io, g-tec teams and Brendan Allison published a good paper in 2019 explaining a lot of the different projects that I know that Christoph has mentioned in different slides here and there over the past couple of days. BrainHack, as I mentioned earlier, NeuroTech X, we're doing some hackathons as well. Brain Drone Race, for those who haven't seen that initiative from University of South Florida. It's not about the developing of the BCI themselves, but more about public outreach and having people controlling drone with their brain with a BCI, using mainly the emotive headset and just kind of like having races of people flying drones. So I think it's a good awareness activity from that group. BCI award, obviously on the other end of the spectrum, way more on the research side and great breakthroughs in the BCI world that everybody knows. I'm really excited to be a jury this year on the 2020 edition. The Cybathlon, obviously we cannot talk about BCI competition now without mentioning the Cybathlon, which encompass different categories of activities, but the BCI one is definitely an exciting one. Nerdlon is the Russian version of the Cybathlon, so they do have as well their competition in Russia. Last year it was at the same time as the BCI Samara conference, a new, not necessarily new, I think it was the third year last year conference going on in Russia about BCI. Neurotech Cup as well, a new initiative for BCI competition Neurotech projects as well. And obviously our own Neurotech X Student Club competition that we're really excited about. The Neurotech X Student Club competition, the idea behind that, as I said earlier, is to have undergrads working on different projects. So the last year's winner was McGill Neurotech, so a group of undergrad at McGill who did a mind control wheelchair. So I know that the project have now been many groups have tried to reproduce their project, which is awesome. All the Neurotech X Student Club projects that are being presented are open source. They have a full GitHub so that people can reproduce the project. They do have a 10-minute video on YouTube presenting the project, the team. So I'm just gonna quickly show you the first, just quickly what it looked like. So they do have a wheelchair, which they hacked and add some electronics so that they were able to control it. They use the OpenBCI and they add also a camera with image recognition to know if you're along a wall, for example, to optimizing the decision-making of the wheelchair. So keep in mind that this was done with undergrads in a student club at McGill University. So really excited to see that kind of projects. If you want to see all the projects from 2019, there's /NTX-SC19. The same team won, so hopefully in 2020 we'll have a different winner than McGill, who's currently obviously the grand champion of the Neurotech X Student Club competitions. They were also one of the, not to take any credit away, but they were also one of the original Neurotech Student Club, so they obviously have a bit more time under their belt that they've been working on different projects. In 2018, what they presented as a project was the famous P300 speller kind of project. So once again, having undergrads learning and exploring projects with P300 spellers, which is a very actual problem in the research space in BCI. Personally find it really exciting to see that they can, as early as their first year, get exposed to such projects and challenge. So they also, what was interesting with their project is that they also played with different symbol, as many people are doing in research. Aside from letters, can we use faces, symbols, emojis, and things like that? And how does that impact the performance? And how can we improve the P300 speller paradigm? So that was an exciting project. On the other side of things with the Neurotech X Student Club competition, what we do is that we do have a fix. So the McGill won the open challenge. The idea here is that they are open, they can do whatever project that they want to do in neurotech. It doesn't have to be a specific medical, healthcare related project. It can be anything that they want to work on that they find interesting. And we do have another category, which is the fixed challenge, where we impose the challenge. For the past 3 editions, it was the same fixed challenge. It was to build a bioacquisition board from scratch. So basically they have to put all the component. The idea for us was, can undergrads develop the skills or at least get exposure in what it means to take a wire, put that on your body somewhere, and then get a signal on the computer and do a visualizer and then probably some Fourier transform and things like that. But we're really focusing on the engineering aspect of the board. We're not expecting to create medical grade equipment, but really just for undergrads to be able to understand what it means to create a bioacquisition board. To do I plug it in the wall? Do I need to be battery power? What it means to be wireless? What's the power consumption when I'm wireless? Wi-Fi, Bluetooth, other. So all these interesting challenges that are part of the wearable world and just the EEG world in general as well. So Polycartex developed their board. Obviously, it's very prototyping-ish, and that's the beauty of these projects. But they also came up with the full. Whoop, I skipped. I'm just gonna go back to. Don't want to play the full video. I just wanted to show that they also worked on. If the video wants to load, on a visualizer as well, showing the signal. So they really did all the board, the signal goes to the computer, and then in Python, they develop a nice visualizer as well. So once again, undergrads, I'm messing up. Okay. Once again, undergrads from Polytechnique Montréal who won the competition this year. we cannot really talk about BCI and EEG hacking without talking about the MindFlex hack, probably one of the most famous EEG DIY hack back 10 years ago. The beauty with that hack is that it was really well documented. So MindFlex was based on the NeuroSky chip, and it was basically controlling it's a toy at the end of the day, and you could reverse engineer part of it and hack in the guy had an Arduino on top of it to get access to the signal and then get it in the computer. What the hack and what these hacks, and not necessarily talking about this one in particular, but the idea behind such hacks is that sometimes it opened doors that research or that other projects would not have opened. In this case, by just hacking that, it inspired other people to give it a go as well. And now OpenBCI we all know OpenBCI was basically born out of after doing that hack of trying to reproduce the hack, then put that in a hat, as we can see on the right side of things, and then OpenBCI was born. OpenEEG also is kind of related to that hack project as well. So sometimes breaking things a little bit and trying to improve things definitely paved the way for other people to reproduce and then go a step further in that direction as well. My first real hack was a neural drift small project, 2014. With the Lego Mindstorm and two people with the Muse headband, basically controlling if you relax or you focus. If you focus, you move forward, and if you relax, you stop moving. So we had a Lego Mindstorm with two kind of like a small tank moving forward, and we have kind of like a maze that we need to move left and right. So the two players kind of like need to focus and then relax back and forth to make sure that we turn left and right together. So that was an interesting small hack project. That hackathons definitely opened the way to just exploring fun. Once again, not necessarily as a research and serious and publishing a paper, but just to develop the skills of building that in like a weekend in 24 hours or 48 hours. Just hacking, I think that it's hard to beat as a ROI of your time of having 48 hours with a team of people where you just hack and you just develop skills. You go over bug faster than you would normally if you're alone at your home and taking it easy and you're not on a rush deadline. So in terms of ROI for developing skills and learning, I think that hackathons are pretty hard to beat. The transatlantic biodata communication that we did in 2015 as well, during the two hackathons happening simultaneously in Amsterdam, in Montreal. Here, what we did is using the backyard brain, HHI, or the TENS, the muscle stimulator that we used. Someone from Montreal was an EMG with the OpenBCI, and then controlling someone's arm in Amsterdam. So we had two hackathons, both connected via Skype. We had a video, so I'm on stage, and there is kind of like the people in the hackathon in front. Same thing on the other side; they are kind of like on stage, and they are all the audience of the hackathon in front, all watching the big screen. And Connor here was controlling someone's arm who had a chicken that would just squeak when Connor would flex, and the EMG signal would be picked up past a certain threshold. We did the same thing with Alpha, so controlling with Alpha. Controlling the arm, and on both sides, Amsterdam controlled someone in Montreal, Montreal controlled someone in Amsterdam. So the transatlantic biodata hack, which was inspired by actually a more serious project. You might remember in 2014 when Gro and all with people at Neuroelectrics did this binary telepathy, where on one side you had motor imagery detecting hands or feet. So if the person wanted to move their feet, it would send kind of a 0. And on one side, and the other side, if the person wanted to move their hands, it would send a 1. So kind of a 0 and 1 binary. On the other side of things, the receiver would receive a TMS simulation to generate phosphate. So for those who are not familiar with phosphine, it's basically if you close your eyes and push a little bit on your eyelids, you'll see kind of this white dots appearing. These are phosphine that we can recreate with TMS by stimulating the visual cortex. So basically, you have one person trying to either think about hands or feet, sending a 0 and a 1, and on the other side, the person receive either stimulation, so see phosphine for 1, or doesn't see phosphine for 0. And then you basically have a binary telepathy communication channel. Now, obviously, sending 0s and 1s doesn't sound like a full telepathy and a full communication system, but if you just think about just the digital world, how it evolved from 0s and 1s back in the days, we can definitely see that we could increase the pace of the communication. Obviously, we're not going to reach a super high speed with feet and hands as 0 and 1s, but I think it was an interesting hack project. Obviously, it's a research project, but these are the kind of thing that I consider more hack than research, which is a fun project to do. Obviously, a media stunt as well, where you get a lot of visibility out of these things. But it's very interesting projects that then inspire others to do other projects in that direction. In a similar two people using TMS and EEG. Rajesh Rao from University of Washington is now well known for doing these small games. Using EEG with SSVEP this time, so not motor imagery, and TMS, the same idea, 0 or 1, phosphine, no phosphine. Receiver is blind, so the receiver is not seeing the Tetris game. It's only receiving either phosphine or no phosphine, and then it makes he makes a decision if he wants to rotate the piece or to not rotate the piece based on the phosphine or no phosphine. And on the sender, it's a SSVP task, so there's a flashing lights, and you decide which one you want to send to the other one, to rotate or not to rotate. In 2019, it was a follow-up from 2013, which they did something similar as well in 2013 with a game from EEG to TMS on the other side of things. So I don't know if we're going to see that in hackathons anytime soon with the TMS. Obviously, the sender is easier to do with the SSVP or the motor imagery EEG system to decide to send a 0 or a 1. But on the receiving ends of things, I'm not sure what we're going to see in hackathons in such project. Maybe with EMG stimulation. I don't know about the phosphine and TMS in hackathons. I haven't seen that happen just yet. But maybe with a muscle stimulation, that might be a bit easier to do. A bit more on the DIY fringe side of things, I would say. You might have seen the cockroach BCI control thing. Emotive headset, but it could have been any EEG really to send. I think that the interesting part is more on the cockroach side of things, not the EEG device. The idea here was to add a little chip implanted in the cockroach's brain to control its motor cortex and be able to hijack and send left and right decision. So here there was with a SSVP paradigm where the person was able to control the cockroach to forward, left, or right with the SSVP and controlling basically the motor or hijacking the motor system of the cockroach. So a bit controversial. Not everybody was excited about that project. Not everybody was positive about doing that on animal and insect. All the judge and the jury of if you're okay with that. I think that these projects are important in the way that they raise questions, they raise discussions, where after that we can talk about safety. So I think that these projects are important to just to enable these discussions on the public place as we're moving forward with the neurotech field. And Backyard Brains actually now commercialized, and they are selling a kit. So if you want to try it, You can buy a kit. You don't have to develop the chip yourself. You can just buy the kit and do it on the Cockroach and plug it with a BCI, SSVP, or other paradigm as well. So another big trend that we're seeing, and we're seeing that more in hackathons as well, but which is the EEG or BCI in VR. So this is a bit of an older slides. Obviously the device has changed a little bit, but we saw early on the Neurable, Luxid Labs, and Traxon is also going in VR, and many other companies now doing EEG is obviously going into VR. But what we've seen is that in hackathons and different setups, we're seeing a lot of people trying to bring EEG in VR for different paradigms, whether it's a BCI, whether it's more entertainment, gaming, whether it's control. Different paradigms are being explored, but this is definitely a big trend that is happening. Not necessarily the electrode being embedded in the VR equipment. Obviously, when it's a hackathon or a prototype or a hack, you just put some pieces together and then put a VR headset on top of it. But this is definitely a trend that is increasing, and I think that is growing also with the VR readiness of the devices. So definitely excited to see more of these projects going on in different hackathons, from research, but also just hack and putting things together and seeing what we can do by bringing some signal. Right now I'm talking about EEG, but obviously other biosignals are interesting as well. And like FNIRS as well, as the cost is going down and we're seeing more open FNIRS project on the horizon. The cost is definitely going lower. We're seeing more wearable FNIRS, which was not really the case a couple of years ago. So I'm expecting also to see some EEG, FNIRS, and other modalities, EMG, EOG, and building kind of multimodal system in VR to bring some value, some control in there. The 3D printing of headsets and electrodes, I think this is, and once again, this is an older slide. I will update this slides, but we're definitely seeing a lot of people interested in the 3D printing of headsets and electrodes. It obviously adds a bit more of a constraint when doing that during a hackathon, because the printing time, reprinting, failing, redoing. So we're seeing that a bit less during hackathons. Definitely in the DIY maker community, a lot of people are interested in 3D printing their headsets, the electrodes themselves, different material, different coating. So this is definitely a upgrowing trend. I'm not sure how we can optimize during hackathons to work on these things, just because there's a inherent limitation in time, both in hackathon and the printing process. But this is definitely something that we're seeing more and more on the scene, which leads also to trying to go in ear. So the EEG as we know it, most of the easy places obviously are the forehead, because you don't have to deal with hair, you're directly on the skin. But why not go in ear at this point and try to see what we can get from there. So bit of research hacks and also more commercial application are starting to rose on the field. A couple of startups have emerged to do in-ear EEG devices. The CEEG grid from Germany is one of the most around the ear or in-ear. This one is around the ear, but when people doing in-ear research, most of the time they're also comparing with around the ear. So using the CEEG grid. So another couple of hacks here that looking forward to do at different to see at different hackathons with in-ear EEG sensors. So what we've definitely seen in the past couple of years is a plethora of form factor. People are trying to put EEG. I'm not saying that it's working. I'm not saying that it's the right way. I'm saying that it's interesting to try and to see what can be done by using different form factor, whether it's headphones, whether it's some headset, whether it's VR, glasses, just the fact that we're seeing a lot of the form factors and the cost of EEG signals have been going down. In a hat, for example, on the right, this will see obviously more and more of these devices at different hackathons, just to see what can be done with them. So once again, not necessarily always the best quality, but exploring what can be done with lower quality, with lower price, as opposed to trying to always bring a 40K system in a hackathon, which obviously is not often the case with research grade and medical grade equipment like the biosemi and other and g-tec equipment. G-tec was, I think, one of the smart company to start also doing a lower cost EEG, and also with the hackathon. So it was a perfect synergy there. So really exciting to see that happening. I'm putting a bit less of the g-tec material because I see that Christoph and around different slides we've had many, so I'm trying to give a different angle a little bit to give more material. So on the DIY scene and open source projects, we've seen a couple of different things on the horizon and different projects that either have emerged out of hackathons or just makers and hackers getting together and working on projects. The ECBCI project is a one EEG channel under 20 euros. So you can buy it and connect it to your phone via the audio jack. You have one channel. You can buy the board as is. You don't have to assemble it, but it's open source. So if you want to assemble it, you can also do it. So if you're interested in that low-end, low-cost biosignal acquisition board, definitely encourage you to look at this project. The free EEG32, which is also another interesting project to look at, which is a open source board, 32 channels, but also you can stack up to 256 channels. I haven't seen that happening or the live signal just yet, but that would definitely be the cheapest or the lowest cost of a high density EEG system. Once again, the quality, how does it compare with other systems? I'm not too sure about that, but this is definitely an exciting project just by seeing more and more open source project where we can help advance the field and lower the cost of such devices as well. Open EIT in the same mentality of open source, but here we're moving from EEG towards electrical impedance tomography. The idea of EIT is, instead of listening to the electrical signal, if I can say, is to write and sending an electrical current in something, the brain, the body, something else. But the idea of sending electrical current and measuring the impedance of that material that you're scanning, let's say, and that you're sending electrical current through, and then you can get a tomography out of that. So you have an example of the image here where there's something in the ball, and then you can definitely detect and locate where that object is, just because obviously the impedance will be different. So you can do that with any material basically, which is very interesting to see. Open source project, very low cost as well. So if this is something that you'd be interested, the URL is down below. The slides will be available, or you can either reach out to me or Christoph. I'll be happy to share all of any and all of the links that have been presented so far. And other open source project, which is more on the FNIRS side of things, HEG-Duino, an open source project here to measure the blood flow. So similar, well, what FNIRS is doing. So hemoencephalography. The idea here is that it's near infrared. So you send near infrared, you can measure the difference in blood flow, oxygenated and deoxygenated blood. And then you basically have a low cost FNIRS device. So seeing these kind of projects appearing, is that the best quality, the best device? I'll let you judge and try, but lowering the cost and enabling other people to do that, compare with other systems, and be able to try to improve. I think it's a very ROI positive thing for the field. One of the things that I like with these low cost projects sometimes are being criticized by the researcher or scientists. The best example in the field, and I'm diverging just a little bit for a quick parenthesis, but a few years ago, the NeuroSky was, I think, the first to get bashed a lot by its EMG. It's not really EEG. It's low quality and all that. Yes, it's all true, what NeuralSky did on the other end for the field is that it enabled a lot of people to first get awareness, hack, try, buy the device, develop skills, and the machine learning pipeline that you learn using, for example, like the NeuralSky device, which might not be as the same quality as other devices, as g-tec, Biosemi, and others, is that the pipeline, the skills that you develop while working on that are basically the same. And also by criticizing what these devices are not doing good, it raises the amount of information for other people to piggyback and improve the device. So for example, when you release a low-cost device, some people in the field that have been working in that and with high-end quality hardware and equipment might be the first one to step in and say, hey, this is not this is not good quality, this is not good hardware, etc. But by challenging and saying why it's not as good, or how can we improve that device, that kind of fight on sometimes the public place or the public forum really enables to up the game, instead of just living with the status quo with a couple of companies just being in the space. But it really it pushes everybody, from the bigger company in the space, from the smaller, from the engineers in the space, from the makers. So it really pushes everybody by just having this discussion. So this is why I'm personally really excited by seeing all these open source things that might not be the best, but they are the one paving the way to subsequent improvements in the field. So what we're seeing right now with the free EEG, the open EIT, HEG Duino, all these devices might not be what we're going to see in clinics in 5 years, 10 years from now, but all the skills that they're helping develop, I think is definitely ROI, return on investment, positive for the field. So it's definitely worth having all these devices, because I think that they raise the bar and help everybody improve in the field. One that I'm a bit less excited about in the DIY space. So a couple of years ago, we've seen DIY TDCS on the rise. It stabilized a little bit, but back in 2014, 15, 16, I would say, there was a lot of interest in the DIY TDCS community, making your own small board with a 9-volt battery, just plugging anode and cathode on your forehead, brain somewhere, and just sending electrical current through your head. The scientific community at first was a bit pushing back against that, and then given the safety issues there was no real safety issue. The only thing is that we don't really know the effect, we don't really control the effect, and we definitely don't have any longitudinal studies to know if you're doing that every single day, what's the effect, and we have no idea what it does on kids' brain, so during development. So the scientific community was clearly, if you stay under the 2 milliamp kind of a threshold, it's okay. We're not advocating you to do it, but if you have to do it, like it's hard to say no, because there is no case of real injury and things like that. So that was for the TDCS, which stands for transcranial direct current stimulation. So basically sending a DC current into your brain. But the DIY TMS is a bit scarier, as you can see with the image, because now we're trying to induce a magnetic field that will induce a current into your brain. And to do that, sometimes we need a bit of a higher voltage to be able to induce such current in your brain. So in this project that is available on Instructables, there is a big disclaimer that the device is the most dangerous thing that the person has been releasing, and that actually you might die if you're assembling it wrong, because you're playing with thousands of volts, so high voltage. So if you're touching, or you're not, the system is not safe enough and you're using wrong, especially if you're going with that device near your brain, definitely not really recommend playing with the DIY TMS just yet. I would stick with other DIY projects rather than the TMS one. So just to conclude, in the different things and projects that we've seen, once again, I'm a big advocate for the DIY maker and trying different things, whether just for fun, just to push the barrier, fringe things. But what I'm heavily against is wrong marketing. So when we're seeing a lot of the different projects that that is appearing on the market that are doing claims like the Mindo project, which claim in the description of the project, it was saying, but you can also use it as a brainwave sensor to record your thoughts or to replay them for yourself or your friends, partner, children. Their brain will understand your thoughts, even if not precisely, of course. This kind of marketing, this kind of promotion is definitely not helpful for the field, as a lot of people don't really know what neurotech can do, PCIs can do. So by doing these kind of marketing inflated claims, this is definitely a no-go. So even during your hackathons, if you're working on different projects, please try to see with experts and other people that might have more knowledge to what's possible, what's doable, and try to stay in that lane as well. Or you can try something that you think will fail, but at least don't try to promote it or communicate as if it would, because right now, there's more and more neurotech discussions on the public place, and the general public might not really know what's possible, what's not possible. So the last thing we want is for general public to start believing these claims that we can mind control things and whatnot. So be careful with the wording and the marketing. Neurotech X don't want to necessarily play the neuro police, but definitely when we see these red flags, this is something that we try to step in and rectify and explain that this is obviously not possible at all. One of the most famous red flags of all time in our field is definitely the no more woof. So during hackathons, it's okay to have fun, to try different things. So if you want to put an EEG device on animals, on dogs, trying to listen to their thoughts and why they are woofing and trying to understand them during a hackathon, by all means, be my guest and have fun and explore that. But do not commercialize or try to bring that communication and marketing on the public place, as this is not really helpful for the field at all. It's not bringing any value for the grand scheme of things. So just to end, I'm definitely a bit earlier than I thought with my talk. Usually it's the opposite. So I wanted to do less this time than to go over time, which is usually what happens. But I want to end on the importance of this kind of scene right now, which I would compare with the Homebrew Computer Club, which was the hobbyist of computer hobbyists in the Silicon Valley back in 75 to 86, where a lot of the people from Apple, Microsoft, from Bill Gates to Steve Jobs to Wozniak were part of that community and going in these meetings, getting together, just hacking on stuff. Obviously, there was this idea of the computer and creating businesses and things like that, but it was really passion. It was not a business place at first. It was more like hacking and trying to improve the field, exchanging ideas. Not all the projects we're seeing right now are the end on themselves, but they are beginning of the neurotech era that we're starting to see. It's different. A place. A lot of the people would like to see that happening. We would all like to see the Matrix and be able to mind control stuff in the next 2 years. Now we do have Neuralink, Facebook, and others trying to accelerate that pace. But people that are working in the field understand that the brain is complex and that we're not going to solve this mystery in just by injecting a bit of capital in a year or two. It will take time, and there is different factors. But I think that the hacking makers community is a very important one to develop skills, raise awareness, and just grow with the field, exchanging ideas. Outside of the research labs, obviously research has its own purpose, and in research lab, the conference and all that space is what is the main driving force. But I would argue that the side lane is also important for developing skills, just having fun as well and exploring ideas that would not necessarily be explored in a research grant, research lab environment. That could definitely bring and yield new ideas and new lane for other people to double down on. So with that, it was interesting. A bit different you've been hearing over the past three days. And I'd be interested to hear any questions and try to answer questions if you have some. Thank you.
So thank you very much for the nice talk. A lot of information, and we have also some questions in the Q&A. So Anatoly is saying, "Hi Yannick, I'm glad to hear you again." And he's asking, how is epilepsy detection competition finished? Which method won this time? Do you remember?
The question is, how did it finish? So the NERCA challenge.
So who was winning the epilepsy competition?
So the two winners were NeuroSyd from Sydney University, or University of Sydney, and from KU Leuven University from Belgium. The main winners of the competition. It was really close with the second and third place with different system, but the second place won because of the electrodes. They were able to bring down the system to 2 electrodes from the 19 in the original corpus of data. So for those not familiar, we use the COVID-19 offline time to throw a epilepsy challenge with the help of TUH, the big data set that was released for epilepsy and other pathology. And with Novella Neurotech, a company in the field, the three of us threw a competition, a month-long competition to try to enable deep learning and AI for epilepsy data. So it's the interesting aspect of that challenge is that in research and in school, I would say we're used to textbook problem, but that data set is really messy. It's coming from years of data. So different hardware, different labeling, different channels at different place. So it's really an interesting real life big data problem as opposed to a textbook problem. So I think that most people that were not in the field, the challenge a bit more complicated, and we'll definitely do more of these challenges, but providing a bit more educational material, because people and that were not part of research teams definitely found the challenge a bit too heavy and intimidating, because it's a lot of data that everybody is used to downloading 50 plus gigabytes of data, handling that, sorting that, and all that. So we'll definitely try to provide more educational resources on that front for further competition.
So Bafia is asking, what do you think is the future of these do-it-yourself projects and hacks at home?
So the future, as I said, of these projects, I think that they are enabling what's next. They are enabling developing skills. Some of them might, actually the best example is the OpenBCI, which became a successful venture impacting in the field. Many researchers would agree that this company is doing great things for the field. And it started with Connor back then reading the Hackatoy blog and decided to reproduce it, had a lot of fun, and said, hey, I think I can do this kit and provide this kit for other people to build on. And now a lot of the EEG companies that we're seeing are prototyping using the OpenBCR, at least developing things, and then they develop their own things. But I think that this is a good example of something. Sometimes it starts with a hack. Some people will start a company that will then enable others. But the DIY project on itself is not necessarily, I don't see it as the business, the value being in creating a business absolutely with these projects, but more developing skills. Anybody that is in engineering or coding would agree that the best type of learning when you want to learn a skill is by just doing it the full weekend without looking at the clock. It's not, you are not tasked to do it. You're just doing it because you're passionate and you want to solve the problem. So what these DIY projects allows you to do is that you want to finish the project. You want to do something and learning all the skills to get there. I think that's where the real value is. And if you can share that journey with other people and bring that DIY thing either as a tutorial or a GitHub repo or something like that, enable other people to try it and reproduce that. I think it's a very efficient way to learn and develop skills. Sometimes it will turn as being a business, sometimes it will change the field, and sometimes It's just a bunch of people that will have developed a lot of skills that will then translate. And when they join a company like g-tec or something like that, then they are way more efficient at working because they've been hacking on that and they've been developing skills working on these challenges, whether it's engineering, electronics, or on the computer science side of things. But these skills will then translate in the real world outside of the DIY side of things.
Okay, and the Human Cockroach project was actually one of the BCI Award nominees a couple of years ago, and the developers were already speakers of the summer school already this week. And Maria is asking, what's the potential application of the Human Cockroach interface?
The potential application, that's a very good question. Well, I actually didn't see their presentation. I didn't expect that they would be here. So that's very interesting. Once again, I think that for me it's similar. It's the learning skills, the trying. Some people might not be as okay with animal and sex development testing. So depending on where you fall on that spectrum, a lot of people are not really huge fan of what Miguel Nicolelis is doing, for example, on monkeys, rats, and animals. Some others are huge fan. So it really depends, I would say, where you fall on the spectrum on these kind of testing. Once again, I think that the main thing is really developing skills and understanding the brain control. Yeah, for me, it's really, I don't see the project itself. I think it's more of an educational and skill developing tools more than an actual product or project that will that will see forth. But maybe the researchers have other intention in mind with actually leveraging that for real to control cockroach in different environments. So I don't know if Christophe, given if you've listened to their talk and if they have suggested any insights in that direction of how to leverage the project further.
Yeah, the Human Cockroach project was just the initial step for the team to go into BCI communication. But nevertheless, it was nominated for the BCI award because, first of all, they were sensing from the brain and they had to develop some signal processing to make sense out of it. And then they electrically stimulated the cockroach and they closed the loop so they could really control the cockroach along a certain path. And you have to remember this was a student's project. And they established everything. So a few years ago, this was completely impossible, and this was just a student's project, and they realized it. For that reason, it was very nice. Juan is asking or saying animal experiments may be useful, for example, to explore spaces with fragile structures, for example, after an earthquake.
Say that again, sorry?
So he's arguing that experiments with animals are useful because you can use it to get knowledge to explore structures after earthquake, for example.
Yeah, 100%. Yeah.
Beside that, you also have to test your neurotechnology before you can use it in humans. And very often people are forgetting that there are just a few monkey labs worldwide, but the ECOG is recorded in every neurosurgery hospital in every single country. So nowadays we get much more ECOG data for brain-computer interfacing than the whole world gets from monkeys, because humans are a much better test case. And they are implanted anyhow for tumor and epilepsy patients. So this is just a very good opportunity to bring BCI technology one further step ahead. So Yannick, this was very interesting. Thank you very much for your contribution. What's the next event that you are organizing?
It's a neurotech gaming. So you might have seen we've started just promoting it recently. I think it's on July 14 to 18 or something like that in mid-July. It's like in 2-3 weeks from now. It's basically BCI and gaming. So if you're interested in that overlap in that space, just go on the NeurotechX website on Twitter, and then you'll be able to get more information about this upcoming event.
So gaming is also a very important aspect of the hackathon. So we have seen very nice computer games, BCI controlled, developed during the hackathons. There was especially a nice project in Miyazaki where they developed a game where one person was using the keyboard and the other one the brain-computer interface, and they could only solve the game if they work together correctly. Okay, so thank you very much. And
thank you for having me.
Greetings to Canada. See you soon.
Good luck everybody with the projects and the rest of the event.
Thank you. Ciao.
Ah, es gibt ja gar nicht mehr.